Okay, start recording. Fine. Okay, so let's start with the basic routing part. Has been okay. Now today we'll talk about the routing. Okay, so we'll go for routing basic first. Okay, so we'll do routing in the on the routers as you already know. Okay,
Yeah.
and we already did in the switching part. So in switching we did the switches, but now we configure the routers now. So we'll do all the things on routing. Okay, so first we need to understand in that we need to understand the first concept is routing. So what is routing? It is a process. You can say that it is the process through which we can create routes. Okay, routing is the process through which you can create routes. Okay, routes, or you can call it's known as path. Okay, so we already know that router works on routes. So we need routing for creating the routes. Now, if we talk about the routing, so or you can go for we can talk about the routing. So we have three types of routing in that case. Okay, types of routing. So we have a types of routing. So in that we have three types of routing. Number one is static routing. Static. Number second, we have dynamic, and number third, we have default. So we have three types of routing in router support. Three types of routing, as you can see that. Now we'll discuss all these three types. Not to worry. So if we talk about the static one, so in static one, okay, we need to create routes manually in that case. So that create routes manually. Okay, in dynamic we can use the routing protocols. Like we have some routing protocols. Like if I give you the route, if I tell you the routing protocols, you have like rip version 1. Okay, uh,
Yep.
rip version 2, as we can see that it's EIGRP and OSPF. Okay, these are the basic routing protocols we have. Okay, we can use with the helper, we can use with these protocols, we can create the routing as well, or we can create the routes in the routers. Okay, so whether we can go for static one or whether we can go for dynamic one, we have two routing processes there. And default means that we're not able to use any route over there, which means I'm not configuring any route in the default. Okay, we are not using the protocols as well. I just go for the default route. Default route means that, like, if I have a router, or I want that if any packets come on the router, okay, it's forward the packet to a particular port. So we can define a single route, as you can see that, in the default routing. Okay, fine. So we'll
Mhm.
discuss when we come in the default routing. Okay, so before we understand these routing processes, or before we understand everything in the routing, we need to understand the one thing we need to understand is that category of routing protocols. As I told you that we have a routing protocol which is mostly used in the routers, whether we have a RIP version 1, version 2, EIGRP, and OSPF. So these are the mostly three routing protocols we mostly use. Okay, we have
Yep.
others also. We have a BGP also. So many things are there also in this. We have BGP also. Okay, but we mostly use these three protocols. Okay, in if you have a small network, we don't have any that much large network, so then you go for RIP or EIGRP or OSPF in that cases. So we'll discuss about the differences also between this in means the upcoming sessions. Now let's talk about the first category of routing protocol. Category of routing protocol. So we have some categories also of routing protocol. We'll start with number one. We have a distance vector. Number second, we have a link state, and number third, we have hybrid. So these are the three categories of routing protocols. So you can say that when you do routing, okay, all these protocols are belongs to if I using the dynamic routing, so all these protocols like Ripv1, EIGRP, OSPF, BGP, and all other protocols are belongs to these categories. Okay. Now in the distance vector, if we talk about the distance vector in that case, if we talk about the distance vector, okay, distance vector in distance vector, if you talk about distance vector category, your RIP and IGRP. You can say that we have a yeah, IGRP is a old version of EIGRP. Okay, first introduce IGRP and then we have the EIGRP over there. So you can say that in distance vector, a RIP and IGRP works, and you can say that in distance vector, uh, it uses or you can say uses hope count. It uses the method hope count to choose the best path. As I already told you in the previous lectures also, that a router works on best path. So in distance vector, it uses what? It uses hope count. Now, what is the hope count in that case? Okay, so if you talk about the distance vector example, so how in distance vector routing protocol works. So like this, like imagine if I have a router over there. This is the routers I have. I have three routers like this. Okay, and these three routers are connected with each other. This is the router one we have, this is router 2 we have, and this is router 3 we have. Okay, and we can connect these all routers like this. We can connect these two routers like three routers like this. Okay, now imagine that router 2, sorry, wants to sends the data packet to router 3. Okay, so what I need to do for this, so router 2 has two ways, or you can say two paths to send the data, whether it's go via router 1, okay, or whether it's go directly with router 3. Okay, so now if we talk about
Yeah.
the hope count means the routers or devices which we have in the array. Okay, so like you can say that if we talk about the router 2, if it goes via router 1, so we have two devices. Router 1 is the first device and router 2 is the second device to reach the destination. So we need to cross two hopes over there. And if we talk about the second way, if it directly goes to the router 3, so it cross only one router, that's it. It's destination router, as you can say that. So
Yeah.
that's what we have a hope count. So distance vector category works on hope count. So like
Both RIP and IRGRP.
yeah, both works on hope count, as you can say that. So
Yeah.
both are the protocols who works on hope counts. Okay, and you can say that if any like so in that case, the best path of router 2 is to directly goes to router 3 like this. This is the best because they have a less hope as compared to the second part. Okay, in first part we need to cross two hopes, but in second part we can cross only one hope. So in that case, distance vector works on like this. So if your protocol works in distance vector, so it uses hope count to judge the best path. Okay, if I
Yeah.
have two you can say that if I have two paths to reach the one destination. Okay, now in link state, if we talk about the link state, so in link state we have, it works on cost. Okay, cost, or you can say that yeah, it works on cost. Okay, or you can say that it's dependent to the cost as well, and we have a bandwidth and delay as well. Bandwidth and delay as well. Bandwidth plus delay. Okay, so in link state, which protocols is working, as you can say that if we talk about the link state, so link state uses work on OSPF. Okay, EIGRP. These are the protocols is works in link state, as you can say that. OSPF and EIGRP are works in link state. Okay, so now we talk about the link state. So link state has a different values. Like if we talk about the link state, so it works on, so your protocols works on number one, bandwidth and delay. Now, what is the meaning of bandwidth over there? Like imagine if I go for the same diagram. So imagine that over there between R1 and R2 are using, imagine 2 Mbps of bandwidth. Okay, between R1 and R3 we again using, the my bandwidth is same, as you can say that 2 Mbps of bandwidth over there also. Okay, and over there I'm using and then the down we are using again 1 Mbps of bandwidth. Imagine 1 Mbps of bandwidth I have. Okay, and you can say that the delay is not there. There is no delay over there. No delay. Delay means there is no traffic, as you can say that in my bandwidth. Okay, so it checks
Mhm.
the delay as well. So delay means if you have any network traffic on the bandwidth, so it checks the delay as well. Okay, so there is no delay in that and all the bandwidths. You can see that I don't have any traffic right now, so there is no delay on all the bandwidths. No delay. No delay is there. Okay, so if now router 2 want to choose router 2 also, I am using EIGRP over there. EIGRP I'm using over there. EIGRP over there. Router 1 also I'm using EIGRP protocol for routing, and I'm also router 3 also I'm using EIGRP, as you can see that. Okay, everywhere I can using EIGRP. So what happens in that case? It chooses the best way with the help of delay and bandwidth. Now you can say that, like, if you see that if he checks the bandwidth over there, so bandwidth is high as compared to down as compared to this path. Okay, so bandwidth over there on this path is high. Over there we can be able to see 2 Mbps and 2 Mbps, but on the down we have only 1 Mbps. So what router 2 chooses the path to forward the router 3 packet is this is the path it chooses the path via router 1.
Mhm.
Okay, it chooses the path by default. This, it doesn't matter how many devices we have in this path. Why? Because link state only works on bandwidth and delay. Remember these things. It doesn't matter how many devices we have on this path. Okay, we need to cross. It's okay. Okay, if your bandwidth and delay is less than the dead path, so it chooses the alternate this path also.
If the delay is smaller on the 1 megabytes,
Yeah,
uh,
but first preference, but it go firstly for bandwidth, as you can say that.
so bandwidth is primary.
Primary and secondary is the delay, as you can say that.
I see.
Okay, like this. So this is what we have. Okay, and the concept of this is that we have a cost too. Now what is the cost over there? Now cost has a formula. Okay, cost is known as 10 raised to power 7 upon bandwidth plus delay. This is actually the formula of cost. Okay, so as you can say that, you understand the cost is that if my bandwidth is high, so my cost is automatically low. If my bandwidth is low, so my cost is automatically high. As you can see that, you can define it like this. Okay, so remember
Mhm.
always that if my cost is low, so EIGRP chooses that path where the cost is low, because I need high bandwidth, of course, in that case. Okay, so the formula
Yeah.
of this is 10 raised to power 7 upon means upon a bandwidth plus delay, as you can see that. Okay, so when we can take the cost. Okay, now in link state, in distance vector, if we talk about the distance vector, so routing protocols make only one table. That table is known as routing table. Remember these things. So in RIP and IGRP, it makes only one table, that is known as routing table. Okay, but if you talk about the link state, so link state protocols works on three tables. Remember these things. Okay,
Yeah.
so in these three tables, name is starts with number one is routing table. Sorry, a
Bless
routing
you.
table. Oh, thank you. Okay, so routing table, this is the one. Now second is known as neighbor table. Neighbor table. Okay, and the third one we call is known as, sorry, spelling, neighbor table, and the third one is known as the topology table. Remember these things. Your link state works on link state protocols, not link state. Your link state protocols works on these three tables. Now, what they mention in the routing table mentions only the best path. In routing table, router mentions the best path only. Remember these things. Best path, whatever best path we have.
Is it similar with the one
Yeah,
used
yeah,
by
yeah, yeah. Yeah, it's similar.
distance
Like
max?
whatever we can create in the distance vector. Okay, it's similar to that. Routing table is always maintaining the best path only. Like imagine that. Like imagine that we have a two path over there to reach the router number 3. from router number 2. So first he chooses the best path, and that best path mentioned in the routing table.
I see.
Okay. Now in neighbor table, we have neighbor table maintains the neighbor information about the routers. Okay, like the router 2 has how many neighbors? If we talk about router
Two.
1 and router 3, right?
Yeah.
So in router 2 neighbor table, it has the information about router 1 and router 3 also. Now, how many neighbors we have in from router 2? Okay, means router 2 has how many neighbors? If we talk about the router 1, so again router 1 also has two neighbors, router 2 and router 3. So it same thing, we can mention, it's mentioned in the neighbor table. Understood? Okay.
Yeah.
Yes.
Now in topology table, what we can mention in topology table, like imagine uh, it mentions the all except the best path, all the paths in mentioned in the topology table. Like imagine that if router 2 wants to forward the data to router number 3. Okay, so router 2 has two paths. Best path is a router through via router 1, because it works on bandwidth and delay. Okay, so the bandwidth is means good as means higher as compared to the second path. So in this paths, the first path mentioned in the routing table, and the alternative paths are mentioned in the topology tables also. Why it mentioned in the topology table? Like, because if my best path is down, imagine if my best path is down over there. Okay, my best path is not working, as you can say that my this bandwidth is down, or maybe this bandwidth is down, as you can say that. So what happens? It automatically makes the alternate path as a best path automatically in that case. Okay, so
Hmm.
it mention all the alternative paths in the topology table too. That if in necessary, if something has happened in the best path, if my best path is not working, or if something has happened in the best path, so what happens in that case? It has at least their alternative path, and then they go for again elections, and then make a second best path. We need to go for that, because the first best path is down already. Understood?
Yeah.
Yes.
So that's what we have. Our three types of routing table works in link state. Okay, and the last one is known as a hybrid one. So hybrid one is what? Hybrid one is works the hybrid protocol, the protocol which works in hybrid category. It works on both distance vector and link state, on both the categories. Means it works on routing, it works on hop count also, and it works on bandwidth plus delay also. So this is the only one protocol which works in hybrid, is known as EIGRP. So as you can say that you can say that EIGRP works on hop counts also, and EIGRP works on bandwidth and delay also. Remember those things. Okay,
Yeah.
clear. So this is the only protocol we have who works on the both the categories, yeah, with distance vector and link state both. Okay, that's why we can call it known as a hybrid, or we can call this hybrid is also known as advanced vector distance vector also. Remember these things. Hybrid has two names. One is hybrid, and second one is advanced distance vector.
Hmm.
Understood? Clear?
Yeah.
Okay. Now we can see the methods also, that distance vector, we are using the hop count to choose the best path. In link state, we are using the cost or bandwidth plus delay to choosing the best path. Okay. So these methods in category wise is known as metrics. What we can call is known as metrics. Understood? What is
Yeah.
metrics? A key value to select the path, as you can say that. In short, you can call it. You can short. It's the technical term. You can say that key value. Key value to select the best path. To select the path, as you can say that, or best path, as you can say, because router works always on best path. So key value to select the best path, or to select the path. You can also say that. Okay, best path or path, whatever you can say. Okay,
Yeah.
as per the understanding. Okay, so this is what we have a key value. So in distance vector, the key value is hop count, and the link state, the key value is bandwidth plus delay. Okay,
Yeah.
and cost too. So this is what we have the key value. So that methods you can known is metrics. Okay, understood. So this is what we have, the categories of routing protocol. So we need to understand these three categories. Okay, now next we understand the metrics too. So the method we are using and in the protocols to select the path is known as metrics. And now we need to understand is the very important thing is known as administrative distance. We can call is known as AD. In short form, we can call AD, and the full form we can call is administrative distance. Okay. Now, if we talk about the administrative distance, if we talk about the administrative distance in that case, so administrative distance is it is used. You can say that it's a kind of a value. You can say that it's a kind of a number or a value. With the help of this value, or you can say that this value provided by every protocol, as you can say that. Like if I talk about the administrative distance, so like imagine if I connect any network directly on the router. Okay, so that directly connected network, directly connected network AD is 0. AD value is 0. Remember this things. I'll let you know why we can use AD. Not to worry. First, we need to understand the value. AD value is 0. Okay, number one.
Yeah.
Okay.
It means that if I have a router and I can connect 10 network directly on the router, so that 10 network value is 0. As compared, means in AD value we can define 0 in that case. Okay, means I'm not defining this AD values. This AD value defining automatically. Okay. Now the second one, we have a static. If I using the static routing, okay, so my best so my so I'm using in static routing, the value is 1. Okay, if you
Yeah.
create the roots manually, so that root value is 1. Okay, fine.
Okay.
Yeah.
Now next we have OSPF. OSPF value is the protocol OSPF. If I create the roots with the help of OSPF protocol, the value of the root is 110. Okay,
Yeah.
if I using the RIP, so value of the RIP best path is 120. And if I using the EIGRP, the value of EIGRP is 90. Okay, actually EIGRP has two values, 90 and 172. So we'll talk about where we can use 90 and where we can use 170. You not to worry about. We can talk about this also. Okay, so so this is what we have the values. Now, why we need these values? The question is this: why we need AD distance, administrative distance in that case? Okay, now I'll let you know why we need this. Like imagine that I have three routers. Okay, and I can use you can say that EIGRP protocol to create the routes. Okay, by default, means you can say that by not by default. I manually configured the EIGRP on all the routers. Okay, and all the routers works on EIGRP protocol. Imagine I'm using over there EIGRP. Okay, router one EIGRP, and over there also I'm using EIGRP, and over there also I'm using EIGRP. Okay, so every protocol using the same every routers using the same protocol, as you can say that. So all the routes value is same, 90. It works on 90, as you can say that. Imagine by default the value EIGRP value is 90. So by default all the routes, all the best path works on EIGRP 90. So we don't need any distance in that case. If I'm using the same protocol to every router. Okay, now imagine that what I do, I have them now changes now, as you can see that right now in router 1 and router 2, I'm using over there EIGRP, but in router 3 I'm using RIP protocol in that case. Imagine. Okay, I'm using RIP protocol to create the routes. Okay,
Yeah.
to create the routes on router 3, and router 1, router 2 using the EIGRP protocol. Okay. Now the question is, now the concept is that, like, if imagine that if this router, as you can say that if this router choose, like, if we talk about the RIP, if we talk about the router 3, so it makes the best path using the RIP protocol. Okay, so if you need to go to router number 2, okay, so he has two paths, whether you go to via router 1 or whether you go to directly on the router 2. Okay, so you can choose the down one path, as you can say that he can choose
Yeah.
the down one path, and you can say that he mentioning the routing table that I'm go with the with this with this path. Okay, now concept is, if I have a different protocols I'm using in the in my network, in my one network, or if you can say that in my company network, if you have multiple routers and if I'm using the different protocols in that case. Okay, so what happens in that case, router needs to choose, like, imagine that in there also, now I'm using the two protocols over there, like over there also I'm using the RIP, over there also I'm using the RIP. Okay, in that case, and over there also I'm using the EIGRP. You can say that right now, imagine that my network is big, so somewhere I can use EIGRP and somewhere I can use RIP. So for communication with each other, I'm using the both protocols to all the routers. You can say that I'm doing some redistribution process. So if you have a different protocols running together, so your router is not able to ping, remember these things like this, if I using like this technology. So router 3 using RIP, and router 2 and 1 using EIGRP. So EIGRP, so router 1 and 2 is able to communicate with each other because they are using the same protocol. But router 3 is not able to communicate with router 1 and 2 by default, because he's using the different protocol in that case. Okay,
Mhm.
understood. So we have,
This
yeah.
this difference between routers is usually encountered in the networks, or is an exception?
It's not a section, actually. Imagine that some happens, somehow some happens, like if I have a very big network, so it doesn't matter, it doesn't mean that I'm using only the one protocol everywhere. Okay,
Yeah.
imagine that I have my big network, so in first floor I'm using RIP, second floor I'm using EIGRP, third floor I'm using OSPF. So we can combine the protocols too also. Okay, so there is
Okay.
one process is known as redistribution. The process name is redistribution. We'll talk about this, not to worry, when you go for dynamic routing. Redistribution, actually, with the help of redistribution process, what we can do, we can combine the multiple routing protocols also. With the help of this, what I do, I can combine these protocols. Okay, these different
Mhm.
protocols, and now router is able to communicate with each other. It doesn't matter whether they are working with the whether it doesn't matter whether it's working with a different protocol, they are able to communicate with each other. Okay, so like
Yeah.
if you want if you like that if you have a different protocols running in the net in the different routers, so we can use redistribution process. With the help of redistribution process, we can connect two or more than two different protocol routers with each other also. Understood? Okay,
Yeah.
now imagine that now router is confused over there. Now, why router is confused? Because imagine that I'm using the two protocols now. Now imagine that over there also with the redistribution, what I tell router 1 that you need to learn RIP routes also, and router 2 also I tell that okay, you need to learn RIP routes also, and I also router 3 to told that you need to learn EIGRP routes also. Okay, so means every protocol learn the two routes now. It learns the RIP routes also, and it learns the EIGRP routes also. Now there the router is confused. Now which protocol routes I'm going to learn in that case? Because we have a different protocols are running in that case. Okay, so
Mhm.
with the help of AD distance, it decides how we can learn the routes, or which protocol is good for me to learn the routes. Okay, imagine if your AD value is high in any protocol, like imagine if we talk about the RIP and EIGRP. Now EIGRP AD value is what? EIGRP AD values is 90, right? Okay,
Yeah.
and the RIP AD value is 120. Okay, so router assumes that if the AD value is low to any protocol, that protocol is trustworthy.
Yeah.
Understood? If any protocol AD value is low, so that protocol is trustworthy.
Yeah.
Okay. If any protocol value is high as compared with the protocol, like EIGRP is a trustworthy in that case, and RIP is not a trustworthy because the RIP value is 120 and the EIGRP value is 90
90.
in that
Yeah.
Yes.
case. So what router chooses? Router chooses automatically EIGRP best paths, and he uses the EIGRP best path to forward the data in that case.
This happens for all three routers. Yeah.
Yeah, like imagine that if we have a different protocols running in a particular router, so in that time AD comes in the picture. Remember these things. When AD comes in the picture, if we have a different routing protocols working, or you can say that in one router we have a different protocol routes. Like in router one, we have a RIP best path uses best path means RIP routes also, and we have a EIGRP routes also in the router one.
Mhm.
So now if router one wants to send the data to router number two, so which route he wants to decide in that. I mean, which route he want to choose. So with the help of AD value, it chooses the route in that case. Understood?
Yeah.
So if
Yes.
you have a EIGRP and RIP, so he always works on EIGRP routes. Why? Because EIGRP distance value is decrease as comparison to RIP value. Okay, so router always thinks that if the AD value, if some protocol routing protocol AD value is less than the other routing protocol, so that lesser than AD value protocol is trustworthy. Remember these things. Okay, fine.
Yeah.
Now imagine that one thing also there. So like imagine that again. Now if right now we're using the RIP and EIGRP and all those stuff. Now imagine that if I using the static routing and we are using the EIGRP both in this condition. We are using the static routing and we using the EIGRP both in every router. So what we can do in that case? Which which he uses? Which route he uses? The static routing route he uses, or the RIP or the EIGRP route he uses? Just forget
Should
about the router three. It go for router
should
one,
you
router two.
should use the static
Yeah, it
because
uses
it's
the static because the value of static is
value. Yeah.
One.
lesser than the
Mhm.
EIGRP one in that case. Understood? Okay.
Yeah.
So
Yeah.
when AD value is comes in the picture, where we have more than
Different.
one more than one protocol or more than one routing method we are using in a particular router.
Yeah.
Okay, clear?
Okay.
Okay, so like this we have this. Okay, and remember these things. If any a protocol AD value is 255, so in that case that case router is not able to reach that particular protocol because AD value, if you talk about the 255 AD value, the 255 AD value is known as unreachable, as you can see that. If any protocol value is 255, so what happens in that case? It not chooses that protocol paths. Okay, fine,
Mm-hmm.
because 255 is unreachable, as you can see that. Remember these things. Okay,
Yeah.
Okay.
so the maximum, the highest value of AD, the highest AD value is 255, and the lowest AD value is 0.
Zero.
Okay, so 0 AD value is like if I connect the router directly with the network. Like imagine if I using over there, like now we can use like this. Like over there, I'm using the IP address like 10.0.0.1 over there, and I'm over there I'm using 10.0.0.2. So as you can say that the directly connected network is what, 10. So router 2 is directly connect with the 10 network. Okay, so this network is known as this network AD value is automatically 0
Zero.
because this network is directly connected with the router 2. Okay, and 10 network also directly connect with the router 1 2. So that's why this AD value is 0 from both the sides. Remember these things. Okay, clear?
Yeah.
Fine. So this is what we have, the AD distance. So remember these things also when we going for redistribution, or when we have a different routing protocols running on a same router. Okay, so in that case, AD value comes in a picture. Okay. Now next we need to understand is we'll talk about the 170 value also in upcoming lectures. Okay, not to worry. Now next we can go for uh, there is a protocol also is known as ISP. Sorry, IRP, not ISP. It's IRP and ERP. Okay, so that and you can say that it's a IRP or IGP also. What we can call it's IGP also. Okay, or ERP, or you can say that EGP also. Okay, so you can call it's known as the full form is interior routing protocol, or you can say that interior gateway protocol. Okay, or you can call is known as exterior routing protocol, or we can go said it's a exterior gateway protocol, like this. Okay, we can call interior routing protocol or interior gateway protocol, or you can say that exterior routing protocol or exterior gateway protocol, whatever you can say that. Okay, so now what is that? What is that in this case? This case we have a you can say that in this case, like imagine if like if I have a router, if I have a three routers, as you can say that router one we have, and we can call it a router two, and we can call it a router three. Okay, so these three routers are working. You can say that these has it is my one network we have. Like this is a WAN network I'm using right now. Okay, this is complete WAN network I have. In that WAN network, I have three routing protocol, three routers is using working, as you can say that. Okay, and this kind of network is known as a WAN network because we're using the routers. Router always works on WAN network, as you already know. Okay, now these both all three routers are using the same protocol, as you can say that. I'm using over there EIGRP also. I'm using over there EIGRP also, and I'm using over there also EIGRP. Okay, so it means that if all my network is means all the router are working in the same protocol. Okay, so it means that this kind of network is known as interior routing protocol network, as you can say that. We can call this kind of network is known as uh, IJP or IRP, where we can use the same protocols. Okay, where my router using the same protocols or same routing type, as you can say that. Whether I'm using this static routing over there, so all routers are using static routing, same routing method, as you can say that. Okay, or same routing protocol we using on the all routers, in the all routers. So in that kind of network we known as IGP or IRP, whatever you
Yeah.
can call it. Okay, now imagine that if I'm using the different routing protocol over there, like imagine over there I'm using RIP. Okay, over there I'm using EIGRP, and over there I'm using again EIGRP. Okay, so this kind of network is known as ERP, or you can call EGP. Okay, where we have a different protocol is running or different routing methods is running, as you can see that. In as you can see that, like this, if I in router one I'm using the dynamic routing. In router two and router three, we are using the static routing, as you can see that. Static routing is this. You can see that like this. Okay,
Yeah.
so this kind of network also known as EGP or ERP.
ERP.
Okay, whatever you can call it, is known as exterior routing protocol or exterior gateway protocol, if you can say that. Okay, understand?
Yeah.
If we have,
Yeah.
if you are using the different protocol or if you're using a different type of routing, whatever you can say that. Okay,
Yeah.
Okay.
so like this is what we have. Okay, so this is what we have in the routing. Now, one thing you need to understand is that the last concept of basic routing is, you need to understand is the last one is known as AS number. AS, AS, we can call it a number. Okay, AS number is known as a autonomous system number. Okay, fine. It is known as a AS number. Now, what does AS number do? Remember when we learn VLAN, what we can do if I need to divide my ports on the VLAN, on the switch, what we need to create. Like imagine I have 10 ports in one switch. Now I want to divide these ports. I want that switch port 1 to port 5 is able to communicate, and port 6 is port 10 able to communicate. But first 5 ports are not able to communicate with 6 to 10 ports, and 6 to 10 ports are not able to communicate with port 1 to port 5. So what we need to do in that case? We can create VLANs, right?
Yeah.
Okay, we can assign VLAN 2, we can create VLAN 2 and assign first 5 ports in the VLAN 2, and we can create VLAN 3 and assign last means port number 6 to port number 10 we can assign in VLAN 3. So what happens in that case? Those those ports are not able to communicate with each other. Understood?
Yeah.
Okay, right? Remember these things in the VLAN concept. Will do, will did. Okay, so same in the AS number also. Okay, what is AS number is that, like imagine in my network, like imagine I have a very big network. In that case, imagine this is my WAN network and I have a very big network. In this network I have 10 routers. Imagine how many routers we have. 10 routers we have. 10 routers is working, okay, in this kind of network, and this is my WAN network, so it's a very big network, as you can see that. Okay, now I want that out of this 10 networks, out of this 10 routers, so my router name is like, it starts with router 1, router 1 to router 10, like this. Router 1, router 2, 3, 4, 5, 6, I R1, R2,
Yeah.
R3, R4,
Mm-hmm.
and so on, so on. So I go for till R10. Okay, these are my router names. Okay, now what I want that R1 to R5 is able to communicate with each other. It's okay. I don't have any issues. Okay, and I want that R6 to R10 router are able to communicate with each other because I'm using the same ports, same protocol or same routing method we're using in that case. Okay, in R1 to R5, we can say that I'm using the same methods. I'm using over there RIP, and over there also I'm using the RIP, as you can say that. Okay, by default, all means I'm using RIP protocol to all the routers. By default, all the routers are communicating with each other because they're using the same protocol in that case. Okay, so by default all the routers are working together, but I want that R1 to R5 able to communicate and R6 and R10 is able to communicate. Okay,
Yeah.
so what I need, I can use AS numbers in that case. Okay, if I need to divide these routers. Okay, so AS number concept working on EIGRP and OSPF. AS number concepts are not working in the RIP. So if I'm using over there EIGRP, like imagine I'm using over there EIGRP now, EIGRP, and I define AS number over there 10, imagine. And over there I can use EIGRP and I define AS number 20 in that case. Okay, so it means that in router 1 to router 5, we have a AS number 10. So it means that these routers are able to communicate with each other. It's okay. But router 6 to router 10 is not able to communicate with R1, R5 now because the router 6 onwards, my AS number is 20 in that case. So what happens in that case? Router 6 to router 10, they are able to communicate with each other, but they are not able to communicate with router 1 to router 5 because their AS number is different. If I using the same protocol, but my AS number is different in that case, so still also these routers are not able to communicate with router 6 to router 10, and router 6 or router 10 also are not able to communicate with router 1 to router 5 because their AS number is
Different. Okay.
different.
So this is like VLANs only
That's what I told you.
in
It's like
routers.
a VLANs, as you can say that. We are using the same routing protocol, but still I don't want to communicate with the routers with each other, so I can divide them into different AS numbers.
Yeah.
Okay.
And AS number has a value. You can define so many groups in one protocol, as you can say that. Okay, AS number starts with 1 and ends with, you can say that, something for 4 million or billion numbers you can create, you can use. Okay,
Yeah.
fine. So like this, we have the division of router networks. If you want to do this, so EIGRP and OSPF only works on AS numbers. Even BGP also works on AS number too. Okay, EIGRP, OSPF, and BGP. All these three protocols have works on AS numbers. RIP is not able to works on AS numbers. Remember these things. Because RIP is a older technology protocol, so it's not using the AS numbers. Okay.
Yeah. Yeah.
So this is what we have. If we talk about the AS number, so AS number is used to, if I'm using the same AS number, so is same also, this condition applied to there also. Like if I using the router 1, router 2 using the same AS number, so we are working over there in IGP in that case, the interior gateway protocol, because these are running the same protocol and AS number. And in router 6 and router 10 also, we are using the same IGP protocol, IGP condition. Okay, IGP network. Okay, but if I connect these two AS numbers together, we can connect two different AS numbers also. Like we can connect two different VLANs also with the help of inter-VLAN routing. Remember inter-VLAN routing concept. Inter-VLAN routing, with the help of inter-VLAN routing, we can connect two or more than two different VLANs. Remember? Okay, in VLANs. Okay, so same in routing also. If I need to communicate these two different AS numbers, we can use redistribution over there. I already told you redistribution. Redistribution is a process. Okay, so we can do
Hmm.
redistribution, and we can communicate these between these two AS numbers also. So if I do like this, so this kind of network is known as EGP, because we have a different AS numbers in one network, and it's able to communicate with each other too. Okay,
Yeah.
understand, Denisa?
Yes.
Right. So, like with the help of inter-VLAN routing, we can communicate in VLANs. Okay, so like same in routers also, if we can use redistribution, so we need to communicate different protocols also and different AS numbers also. Okay, remember these things.
Okay.
Fine. So like this, we have a concept of EGP, and in both the conditions, like in protocol also, and in AS numbers also. Okay,
Yeah.
so this is what we have, the basic concept of routing. I hope you will understand these things, right? Okay.
Yeah.
Just a minute. Okay. Okay, so as you can say that, we'll do some basic commands also in the on the switches. Remember, we can change the host name, we can set the enable password, we can set the telnet. Okay, fine. That these all commands are also working on the routers too. Okay, so I'll showing you all these commands also, how we can run the access the routers, and how we can run the basic commands which we done on the switches. Okay, so we'll
Yeah.
do those basic commands also, and then we'll go for the routing concept, the basic routing concept. We'll understand those things. Okay, fine.
Yeah.
We'll
Okay.
start with the static routing, and then we can go for dynamic one. Okay,
Yeah.
so now onwards, we'll use, as you can say that, we'll do now onwards the we'll do practicals on GNS. Okay, so I'll showing you the GNS. Okay, we can do those practicals on packet tracers also, but sometimes some commands are not working on packet tracers as per the routing mostly. Okay, Fine. So that's why we use GNS in that case. GNS3 I have. Okay. So you can also download this GNS with your site. Okay. And you need images also. So you need to download the images. I means iOS images too. Okay. And I'll let
Mhm.
you know how to configure the GNS. Okay. So you can run these commands on packet tracer also. The basic command is run only the packet tracer, but if you go for some advanced commands, so sometimes packet tracer is not you're not able to run that advanced commands on packet tracer. Okay, so this is actually the GNS3. Okay, fine. And right now I have a 2600 series router. Okay, 2691 series router we have. So I need to, if you want to use the different series of routers, so you need to add the images in this. So if I showing you, if I click on edit, and we can go for preferences over there. So I need to, I already download the images, and I can already add the images. As you can see that if I go I hope over there VM dynamics in iOS routers. As you can see that I already have the 2691 series routers images there. Okay, if you want to add another image, just click on iOS routers and click on new over there, and you need to define the iOS image. Run this iOS router on my local computer, click on next, and you can define the image. As you can see that right now I have only one image. You can see we have other images too also. So if I go for the another image, I go for this, click on this image, 37 series router. Okay, if you have a new image, just click on simple new image over there. I need to go to browse. Okay, and you define the path where you want to add the image. Okay,
Yeah.
okay, and you can define the image. Simple, click on next and finish. That's it. Okay, so I already defined the image. As you can see that I'm using 2691 series image. I have already. Okay,
Yeah.
so you can go for that also. Okay, so right now, as you can see that is showing me 2960, 2600 series routers. Okay, so we'll use for CCNA, it's okay with me. We can use 2800 series also, 2600 series also. Okay, we can use these routers. It's okay for CCNA level. Okay,
Yeah.
so I will go for these things now. So I'll just attach the router. As you can see that here is the router. This is the router one. As you can see that now, understand this also, that if you work on GNS, so I don't have a switches and PCs are there in the GNS. Okay, like in packet tracer we have a switches and PCs also there.
Yeah.
Okay, but in GNS we have a PCs and switches, but we need to add the images again, like how I can add the image to the router. Okay, if you want to use the switches, see they have the option also. Like if I go to there, so we have the option switches, Ethernet switches. But if I need to use this switch, we need iOS image, because you already know that in switches also we need to save the iOS. Okay, we need
Yeah.
to run the iOS, so we need to add images. If you have images on the switches also, you can use the switches, but right now I have only images with the routers only. So now how we can testing now if I do anything on the router, so how we can test in that case? So what we can do, we can use over there loopback connections. What connections? Loopback.
Mhm.
Okay, so if I showing you on the diagram, like if I open once the paint, so like over there what I need to do now imagine this is a router. This is the router 1, router 2, and router 3. Okay, so it is router 1. So if we don't have a switches or systems, means if we don't have a LAN network, okay, in my lab, so for testing purposes, what we can use, we can create loopbacks on the routers. So that loopbacks is working as is working as a LAN network. You can say that. Understood? Okay, so
Yeah.
we can create over there
Okay.
loopback. Okay, over there loopback and over there loopback, and I can connect these routers with the cables. Okay, and we can set the loopbacks over there. Okay, so like imagine over there I can set the loopback like imagine over there I can use 10.0.0.0 for this network I'm using for this loopback. This is a loopback one. As you can see that we set the IP address only, but I showing you the network. So the loopback one I set over there starts with loopback 0. We'll start with the loopback 0 always. Loopback 0 means loopback 1. The loopback 0, and the ID I use is 10.0.0.0 over there. like this. This is the LAN 1 I have, and now over there I can set another loop back 0, and the over is 11.0.0.0. This is my LAN 2, and we have a again loop back is there, loop back 0, and over this 12.0.0.0 like this. Okay, so we have three LANs. One LAN 1 I'm working in 10 network, LAN 2 working in 11 network, and LAN 3 working in 12 network like this. Now assumes that over there we have switches and PCs are working.
Yeah.
Okay, so in
Oh,
GNS we don't have switches and PCs, so instead of that switches and PCs we are using loopback in that case. Okay,
Yeah.
okay.
so this is what we have now. Now these are the LAN connection we have, so you can call this is the LAN connections. This is LAN, we have LAN 1,
Mm-hmm.
LAN 2, and we have a LAN 3 like this. These are the LAN connections we have: LAN 1, LAN 2. Please understand this because we do the practicals like this now, GNS. So now we have a WAN connection to over there. So over there, what we need to do now over there, if I use the IP addresses, so 10, 11, 12 I already used. Over there, I'm using 13.0.0.1, and over there I'm using 13.0.0.2. Okay, like this, because in both the ends of routers, we have a same network. Remember these things. In one cable we use same network. Remember these things. Okay. Over there
Yeah.
we have 14.0.0.1, and over there 14.0.0.2 like this. Okay, and these has two WANs we have. You can say that this is the WAN we have. This is the WAN we have. This is the WAN connection 1. You can call it WAN 1. It's not an, it's WAN 1, and we have a WAN 2 over there. There is the WAN 2. Okay, and this is the part of LAN 2. Not to worry about this also. This port is also a part of LAN 2. This port is also a part of LAN. This port is known as a default
Mm-hmm.
gateway. Default gateway for this loopback. Okay, so this is the
Yeah.
default gateway, and this is the part of LAN 2. Not to worry about it. So this is the default gateway. This port. This is also a default gateway, and this is also a default gateway. And what IP address I can set? Whatever I can set on the LAN. So over there also I can set the 10 range IP address over there. So 10.0.0.1 I give over there. Imagine 11.0.0 give over there, and 12.0.0.1 give over there like this. Because this is the configuration we can do on the routers. Understood?
Yeah.
Okay.
Yes.
So this is what we have. Okay. Now before I start the routing, or before I start the configurations on the router, okay, we need to understand the router ports too. Like we have a router ports modes. I already told you that we have a modes: user mode, configuration mode, privilege mode, global configuration mode, if configuration mode, telnet mode. All the modes are same on the routers too. Okay, whatever we can talk about in the switches, all the modes are same in the routers too. Okay,
Yeah.
understand? Now over there we have the ports, so we need to understand the ports on the routers. We talk about the ports. So first port is serial port. Remember these things. Serial port. Now we can connect router to router to with the serial port. Remember these things also. So this port is used to connect router to router. Okay. Number second, we have Ethernet ports too, because they have fast Ethernet ports too. So these ports are also used for router to router, connect router to router. Okay, or we can connect. You can say that router to switch. Okay, and we can connect. Yeah, we can use go for and router to PC also. If you want to connect router to PC, we can use still the Ethernet port. Okay. Now second, we have a console port. Third one, console port. So console port, you already know that to take the console. Okay, so it's again go for router to PC to connect the router console. Okay. Now, fourth port we have is known as aux port. Aux port is used to connect router to modem. If we have a modem, okay, so if I need to connect my router to modem, so we can use aux port. Understood? Okay.
Yeah.
Now, we all these ports, we know all these ports. Fast Ethernet port we already see on the switches and routers also in like when we go for interval and routings over there, we can place one router and we have a switch. Okay. And console port is also knows that. Okay. Now we talk about the serial port first. Now what is serial port? Serial port is look like this. If I'll showing you the serial port on the routers. Router serial port. It's look like this. See. Router serial port is look like this. This is the old serial ports, as you can see that. These are the old one. Okay.
Yeah.
These are the old one.
Okay.
Okay. And if I talk about the new one, so this is the new one actually now. Have you seen this ports? The small one. This is the new CL ports we have. Okay. Now the concept is that why we can use CL ports to router because as I already told you that we can connect use fast Ethernet port also to connect router to router. So why we can use serial ports? Now on serial ports we can define the bandwidth also, that how much speed I need to connect the routers. Okay, like imagine that.
Mm-hmm.
Like imagine I will give a very good example. You will understand this. Like imagine that if I have a router over there, router one. Okay, fine. And we have another router, router two. Okay, router two. Okay, now imagine that this router has a CL port. Okay, so we have a CL port over there and CL port over there. Now router one CL port speed, imagine speed is 1 Mbps. Okay, fine. And router 2, actually CL port has that not that much speed, so we'll go for the conceptual ones. We'll go for like imagine router 1 CL port has, imagine you can go for like, okay, we'll go for 1 Mbps because right now we have that much speed of CL ports. Now we have on router 2 we have a 2 Mbps CL port. In that case, CL speed means the CL speed of router 2 is 2 Mbps in that case. And now I can connect the wire with CL1 to CL2, means this CL port to this CL port. Over there also we have a serial port. So my serial port number is, as you can see that, like it starts with S0/0. This is the first serial port on router 1, and the port over there, the port number is S0/0 over there also, router 2. So I can connect ports, serial ports. Now what happens in that case? When they transmit the data with each other, so what happens in that case? This serial port is slow as compared to router 2 CL port, right? Right? This CL port is slow as compared to router 2 CL port. Router 1 CL port is slow, as you can see that. Okay, as compared to router 2 CL port. So what we can use, we can define the common speed also between these routers. I want that, okay, don't want to use these speeds. You both of you use the speed. Like imagine I want to go for that. Both of you can use the speed 512 kbps only. So I can define the CL the port speed also in that case. Okay. So what happens in that case? If I define the port speed, so what happens? These two ports are now working on same speed. So in that case, the data transmit is very easily. Okay. What happens if I not define the speed over there? So he sends the data slowly, and he sends the data fastly in that case. So,
Mm-hmm.
so router 1 able to receive the data slow, and router 2 able to send the data fast in that case. So it's a queue in the bandwidth, as you can see that. There's a long data packets queue in the bandwidth in that case.
Yeah, I have a question.
Yeah.
What is the advantage of the serial port connection?
That's why I told you the advantages is that if you have different speeds, so you can define the speeds over there.
I see, but wouldn't we be able to do this with fast Ethernet port?
Yeah, we can go for fast port also. Okay, but in serial ports, by default, the router works on serial ports, as you can say that. Okay, now we have a technology to connect the router to the fast internet, because in the in the live scenarios you can see your router to router connects with the fast internet ports or gigabit Ethernet ports. Okay,
Yeah.
but previously we can use the serial ports. You can say that. Okay, now in serial ports we have two ends. One is DTE and second one is DCE. Okay, so we can define the speed on DCE always. It is known as data terminal equipment, and we have a data communication equipment. You can say that. Okay, so we always define the speed. You can say that this is known as a clock speed. You can say that. We can call it a clock speed. Okay, so we always define the clock speed on DCE end. Remember these things. Okay, fine.
Hmm.
So this is what we have the benefits of CL port. But right now onwards, we've not mostly use CL ports, as you can say that. In live scenarios, we use gigabit Ethernet port or fast Ethernet ports to connect the routers too. Okay, but if you can see the CL ports, okay, using in the router, so you need to understand these concepts. That's why I'm showing you that's why I told you that these concepts, because right now also some networks you found the CL ports. Okay, connect the routers. They're using the serial port cables and serial ports to connect the routers. Okay, so you need to understand this concept. If you found the CL ports, that how CL port works. Okay, fine. So this is what we have a CL ports, and if I showing you the serial cable, so if you go for, so this is the serial cable we have. Router serial cable. So this is the serial cable we have. Here it is. This is the old version. This is the old one. Okay, not this one. I hope it's showing you the perfect cable. Here it is. This is the old one. DT and DC end. So so one is a DC DT end, and one is a DT end. Okay. So we on the where we can mention the speed, we have a on that side is a DCE end. Okay. And if I'm showing you the latest one, so the latest one is look like this. It's a very thin one. So it's not showing me the latest one. In that case. Hmm, yeah, this is the latest one. Okay, fine. It's mentioned also the DT and DC. So on the ports on the cable also it's mentioned which end is DT and which end is DTE and which end is DC. Okay, so you don't need to worry
Yeah.
about that. You don't need to worry about that how we can recognize. Okay, or you can recognize on the ports also. Okay, fine, when you plug the cable. So this is what we have, the DT and DC concept. Okay, so we can use like the CL port too. Okay, so now if I go to my GNS, so we have the option, like if I connect these two routers, router 2, I have two routers now, router 1 and router 2. Okay, and if I go to cables over there, so this is the cable option is there, the last one. Okay, and I can use the cables over there. Okay, where we can use the cable. So right now I have only fast Ethernet ports on the routers. Router 1 also I have two fast Ethernet ports, and router 2 also I have two fast Ethernet ports. Okay, now if you want to attach, if you want to use CL ports too, so right now my router doesn't have a CL ports. So if I need to attach the CL ports, so we can add the CL ports to on the routers with the physical hardware, as you can see that. Okay, so once you click on router, okay, just right click on the router and we have the option. I think configure option is there maybe. Yeah, configure. Once you click on configure, we have the option slots. Once click on slots, over there we can assign the serial ports also. So if I use the CL ports, so I can use this one, NM40. This is the CL port. Let's click on that 40 and click on apply and okay. That's it. Now we can add this successfully in CL ports. So if I go for there, so they're showing me we have four CL ports. CL hyphen CL10 slash 11, 12, and 13. So we have four CL ports are there. Okay, so now
Okay.
Yep.
this is the simulator. Now if you want to assign the CL ports on the hardware, so you can say that we have this, the like if you see the routers closely, your router, Cisco routers, not this one. This is the 2800, 2600 series. Okay. So here is the router, as you can say that. And you can see the space out there. See the space over there. I was seeing the space. Okay. So there is one card is there. Okay. By default, this space look like this. Okay. Not by default it look like this. It's look like this. Like you can say that like this. But there is no ports are there on this particular device. Okay, so if you want to add the serial ports on this particular router, so what do you want to do? You need to purchase the card, the serial port, the card, and you can use this, open this screw. Okay, like this. See, you can open this screw and you can place the card on the back of the card. You have the serial port, and you can just open the screw, place the card, and close the screw. That's it. Simple.
Yeah.
You have seen the screw we have. Okay, simple. Open the screw, place the card, and and close the screw. We have the so if once you put on this, so we have like this. Like this, you can find out the like this. You can put it like this. So this is a CL port we have like this.
Mhm.
Okay,
Yeah.
understood.
Okay.
So like this is
Okay.
a very easy task to place the ports, as you can see that. Okay, fine. So they also want, gives you the warning also that if your switch is on, so don't attach the interface cards if your power is on. If your router is on, don't go for that. Once you're off the router, then you can go for that. So we have the off button also, the routers. Okay, so if you see, there is a off button also in this. Okay, this is the off button and this is the power plug we have. Okay, so on the routers we have on off button too, so you can just off the button and you can use this. In packet tracer I'll showing you the properly, because in packet tracer they're showing you the proper router interface. As you can see that, I'll showing you. See, yeah, if I go for the router like this, and if I open the router, and you can see that is the back side of the router. If I zoom in, here is the router. You can see that now there is no ports are there, and you can see that by default the router power on is on. There is they shows you the green light. If I need to off the router, so I just simple plug off this, just switch off this router. Okay, and we have the
Yeah.
ports over there. We have the ports like 4E ports or 4S ports. So I go for 4S, means I can attach 4 CL ports. A simple like this, we can attach the ports. And then after that, if you want to go for Ethernet ports also, so we can go for Ethernet ports. Like this is the Ethernet ports we have. Okay, I need Ethernet port, I plug it. Okay, okay, the module is not compatible, we need to use the compatible module, maybe,
Smaller one.
or the smaller one. Okay, so maybe I don't have any smaller one in this case. No, we don't have smaller one. Okay, so like this, we can attach the port, and then we can on the router in that case. So now we find out these four ports on the router in that case. Okay, this is the way how we can attach the ports. If you don't have ports on the router, so you need to attach like this. Okay,
Yeah.
fine. So this is what we have. Okay, like same. Okay, so like this on the hardware we need to do like this. On the softwares we need to do simple. So as you can see that I attach 4 ports. Now it is showing me the summary also over there. Once I means put my cursor on the router one, so they're showing me that we have 2 fast Ethernet ports, 0/0 and 0/1 with 2 fast Ethernet ports, and we have a 4 CL ports. Okay, now I'm going to attach the CL ports to the router 2 as well. So I same thing, I go to right click on the router 2, click on configure, and we can go for select ports slots, and just go for slot 0 is already configured on the 2 interfaces. Now slot 1, I go for that, and I can use an NM4T. So 4T means 4 CL ports. Click on apply and OK. So as you can see that if I go router on 2, they're showing me that we have a 4 CL ports also. CL
Yeah.
1/0 is empty. They're showing me empty and all this. Okay, so now we need to use the cable now. Okay, so let's just start with the cable. So there is a cable over there. Okay, the link, and we need to define on which a link I want to connect with the router to. So I can use CL port. Imagine that CL 1/0. Over there we can connect with the CL 1/0 like this. Head is connected. As you can see that it's connected now. Okay. Now, if I need to see the port numbers over there, so GNS is very good in that they're showing you all the port numbers also. This is the option we have. If you click on this, they're showing you the port numbers also. This is the port one, this is the port this, and this is the port number is this. Okay. In GNS, we can see the port numbers too. Okay. Like in packet tracer,
Yeah.
I'm not able to remember that sometimes what the port number I can connect with my switch. So in packet tracer, I'm not able to see. Okay, but in GNS we're able to see like this. This is the option we have: show and hide interface labels. So over there they're showing you the labels also, at which interface you want to connect with the router 1 and router 2. Okay,
Yeah.
fine. Now we need to connect the routers, start the routers. So we'll go for right click on that, we have the start option is there, start router. Okay, now if you want to start one by one, you can go for one by one also, or we have the simple play option. So once I click on this play option, so it start all the nodes, all the routers at the same time. Okay, so let's start both the router at the same time. So go to press this play button, and you can say that the router is going to start. As you can see that, see now it started. They're showing me the green option is
Mhm.
there. So it means my router is started. As you can see that on the right hand side also they're showing you we have two routers, router 1 and router 2, and it started. They've turned into green. Previously they're showing me red. Now they're showing me the green now. So that's why it means that my router is started successfully. Okay, now if I need
Yeah.
to access the console, so over there just right click on that, we have the option console option is there. Okay, once you click on console, so you can find out, you can see the router console also. Okay, there is no very small syntax is there, so you can modify this console also. Just go to change settings, and over there we can go for I think appearance. In appearance we have, I forget it, keyboard. Okay, I forget the options. Okay, here's the font size. As you can see that see font settings. Okay, click on change over there, and we can change the font settings. So now I want to big the font. You can say that, so go for 14, or 14 is okay with me, and click on OK, and click on apply. Now your font is increasing, so now you're able to see clearly. Okay, now it's working as a live device, as you can see that. Okay, and remember that in GNS, we are not able to use user modes in GNS. Like you can say that right now I work on the privilege mode. The hashtag is this,
Mhm.
and my router name is automatically renamed. It's R1. They're showing me. Okay, if I
Yeah.
if I run on the router on the packet tracers, in packet tracer, what they're showing me? They're showing me like this. If I see, you can say that. If you go to there, so they're showing me router, the user mode also. Okay, and if I enable it, so then we can enable the privilege mode, and then I need to change my router name. So we need to do like this in packet tracers. It's run very scratch. But if you talk about the GNS, so GNS, your router starts with privilege mode. Okay, there is no user mode shown in the GNS, and your router host name is already changed. We don't need to change. It is not recommended to change the host name, the router name, as you can see that. Okay, fine.
Yeah.
Yeah.
Like this. So same, I can access my router 2 as well. So I go for router 2 console. Same, I need to change once. I use 14, and okay, apply. As you can see that now it's okay then. Now right now I'm router 2, as you can see that. Okay, so let's see. So now I'm showing you how we can make the loop backs and everything. So over there I can use the loop backs. Okay, so down I am using the loop back. So loop back is there also. So loop back 0 I can use, and over there I can define the network as 10.0.0.0. Okay, or the loop back, and loop back means 10.0.0.1, as you can see that. Okay, on the loop back. So it work as a LAN connection for me. Over there also I can define the loopback 0, and over there I'm using 11.0.0.1. Okay, IP address on the loopbacks, and over there I can using 12 over there, 12.0.0.1, and I have only the same cable, so we can use over there is
Dot,
12.0.0.2.
dot two.
Okay, because we have a same cable. The cable is same, so that's why the end of the IP address is same. Okay, by different, remember that the different that it should, the router WAN IP address should be different to all between all the LANs, between these two LANs. Okay, so now let's see how we can configure the routers. So I go to router 1 over there. Okay, and now I'll define the things. I go to config t and we go for interface. So our interface is s1/0. Okay, as you can see, already see that. So you need to define the IP address 12.0.0.1 and go for 255.0.0. So class A, and go for no shutdown. No shutdown is to up the port. Okay, now exit. Now how we can go for the loop back? Simple, write down over there interface loop back. Now you can see that how many loop back we can create. See the numbers. See this much amount of loopbacks we can create, be able to create. Starts with 0 and end with this number. Okay, so I'll
Yeah.
start with 0. So I'll go for 0 first loopback and go for IP address 10.0.0.1 for this loopback and go for no shutdown. Okay, now I'll go for show IP interface brief and enter it. You can say that we have our CL interface. The IP address of CL interface is 12, and the port is up, and the protocol is also up. And in loopback also we have the interface set the IP address 10 over there. Okay. Now I'll same do in the router 2 as well. So I go for router 2, and now we'll go for config t. Right now I'm in router 2, as you can say that. So I'll go for interface first s1/0 IP address 12.0.0.2 255.0.0. Go for no shutdown. Okay, fine, and then click on exit. Now go for interface loopback 0, and then go for IP address what 11.0.0.1 255.0.0. Okay, go for no shutdown. Clear?
Yeah.
Okay. Now let's see that. If you
Yeah.
go to show IP interface brief, so as you can see that we can set the serial interface on 12 and loopback is 11, like this. Okay, fine. So now if I try to ping with the 12 range, so I'm able to go for that, but I'm not able to ping with the 10 network right now because I don't have a route. If I show at what routes they have, this outer 2 knows. So go for show IP route. If I need to check the routing table of the routers, the command is show IP route. Once you enter it, they're showing me that he knows only two routes. Which route? 11 and 12. 11 and 12 only. He's not able to. He doesn't know the 10 route. As you can see that. Okay. So as you can see that, why it knows the 12 these two routes, because these two routes are directly connected. As you can say that C
Yeah.
over there, C means directly connected. It's connected. So as you can say that 12 network is directly connected with the router 2, and 11 network is directly connected with the router 2. So that's why it knows this. This is the directly connected routes only. It doesn't know the 10 network. So that's why he's not able to ping with the 10. You can say if I go for ping 10.0.0.1, he's not able to ping with. Why? Because he doesn't know the route. So he's not able to
Hmm.
see.
Okay.
He's not able to ping. Okay, if I try to ping with 10, 11, and 12, so he's able to ping because he knows the route. Okay,
Yeah.
like if I ping with 11.0.0.1, so he's able to ping. See, the success rate is 100%. If I able to go for ping with the 12, you see he's able to ping. Why? Because the success rate is 100% because he knows the a 12 network route. Okay, if he able to ping with this, like see, till now I'm able to ping, means I'm able to ping with the router 1 12.0.0.1 also. Right now I'm in router 2, as you can say that. So my router 2 IP address is 12.0.0.2. Okay, and I'm able to ping with router 1 because he knows the 12 route. That's why he able to ping.
Yeah.
Okay, fine. If I go to my router 1, as you can say that, and we'll see which route he knows. Go for show IP route, enter it. Now which route he knows? He knows only two routes, 10 and 12. He's not able to, he doesn't know 11 route, as you can say that. Okay,
Yeah.
because 10 and 12 is directly connected on the router 1. Okay, so he's able to communicate with 10 and 12, but he's not able to communicate 11 because he doesn't know the route. So for configure the routes, we can go for routing in that case. Okay.
Yeah.
So
Okay.
we'll go for routing. So we'll start with the routing in that case. So let's start with the routing now. So if we talk about the routing, okay, so we'll start with the static routing, as you can see that. Start with the static routing. So static routing, what we need to do, we need to assign the routes manually in the static routing. Okay, fine. Like if we talk about the routes in the static routing, so why how static routing works, as you can see that. Okay. So we have a command, we can say that. Okay, we need to understand three things in static routing. We need to define the IP route command. Number one, we can use IP route command to configure the routes on static routing. Okay, IP route command. Number second, we need to define the destination address, destination network, not IP address. Okay, we need to define the destination network address, network address. So how we can define the network address? Like if I need to reach 10 networks, I define 10.0.0.0. Okay, I don't define the one over there. If I define the one, it means that I can define the IP address. I'm not defining the network. If I define the network, so we can the network represents all three zeros. Remember, if I need to define the network 192.168.1.1, I imagine that I need to define the network 192.168.1 dot zero. So this is the network we have using right now. Okay, if I need to define the
Yeah.
network 10.1.1.0, so this is the 10.1.1 network I'm using right now. If I'm using the 10.0.0.0, it means I'm using the 10 network in that case.
Yeah.
Then third, we need to define the destination mask as well. What class you are using over there? Network mask, subnet mask. Mask means subnet mask. Okay, so my subnet mask is 255.0.0.0 in class A because I'm using the default IP addresses or default mask. So we can go for destination network mask, subnet mask is this default mask. Okay, and then the last one, the fourth one, we need to define the next hop address. Next hop address means my next router address. Okay, now understand these things carefully. See, next, what is the next hop address? This is the very confusing thing. For if you are fresher in this, so we need to. It's a very confusing thing like this. Like, see, now understand these things now.
Yeah.
Yes.
Now understand that right now I'm in router one. Imagine, okay, I'm in router one. Okay, and router one directly connects two networks, okay, 12 and 10, right?
And
So
yeah.
router one has these two routes, 10 and 12. Now I need to create route 11 route also on router one. Okay, so what I did on the router one, I'll go for router one and run the command IP route. Now where I need to reach
11.
11. So my network is what? 11.0.0.0, right? I need to define the network ID. I already told you, right?
Yeah.
Okay. Now I need to define the mask. So mask is 255.0.0.0, the default mask I'm using over there. Okay, on the router 211 network. Now we need to define the next hop. Now who is the next hop for router one? Who is the
After
next hop
2.
address? Router 2 is the next hop. Next hop means my next router. So my next router is what? The router 2. Okay. And who is the next port of the router 2? Like imagine that right now I'm working in where is my pencil? Like imagine that if I working over there, um mm, just wait, I lost my pencil. No. Here it is. Okay, now imagine that if I go to there, I need to reach there. Okay, remember these things. I need to reach there. So how I can reach there? On which port I need to cross? First, I need to cross this port. So this is my port. Okay, I need to define over there the next hope port over there. Next hope port is who is my next hope for router one. Next hope is router two. Okay, because I need to go this way. Okay, and the next hope for router one is there is the next hope now. Understand? Who is the next
Yeah.
hope? This is the next hope. hope port, as you can say that. Router 2 is my next hope, and the next hope port is this, because my router 1 attached with this port. So router 1, for router 1, this is the next port for 11. Okay, so what I need to define over there is, I need to define over there is over there I need to define the next hop address. Either I can define the next hop address, the IP address, or I can define the next port number, whatever you can go for that. Okay, so either I can define over there is 12.0.0.2, or we can define port number is S1/0, whatever we can define in this.
We are referring to the port from our router, from router 1, or from router 2?
Router 2 port
Router
number.
2. Yeah. Okay.
So my IP, my router, I am defining the router 2 IP address, no, over there. Okay, the port
Yeah.
which I directly connects with. So as you can see that router 1 is directly connect with the router 2 port, this S1/0.
Yeah.
So
Okay. I understand.
S1/0, yeah, if I define the IP address of S1/0, or if I define the port, it's up to me. Whatever I can define over there. Either I can define the port also, and then I define the port number also. It's up to me completely. Okay, so if I need to create the route on router 1, I can define like this. So remember always that if I go for if I go for static routing, so we need to understand these four things. Okay, number one,
Yeah.
I need to use the IP route command to create the route. After that, we need to define the destination network and the destination mask, and then we can define the next hop port or next hop address. We can call as known as next hop address, or we can call as next hop port, whatever you can say as per the understanding. Next hop port. Understood?
Yeah.
Clear?
Yes.
Denisa, understand, right?
Yes.
No confusing right now, right?
No.
Okay. So let's see. Go for that. Let's create the route now. So right now I'm in router 1. Just try to understand now carefully. So we'll go for router 1. So IP route is works on configuration mode. So I go for config T and go for IP route. Okay, the command is IP route. And now what I need to define, I define the destination. So my destination I want to reach with, where I need to reach, I need to reach 11, because 10,
11.
10
Yeah.
and 12 I know already. I 10 and 12 I know the routes, but I don't know the 11 routes. I need to go to 11. I go to 11.0.0.0. I define the network part. Now we need to define the subnet mask. Subnet mask is 255.0.0.0. Now go for question mark. They ask you what you need to define over there, forwarding router address. Okay, or you can go for other things. So you don't want to go for other things, you can say that you can go for next hop address. So my next hop is router 2, and the hop address and the hop port which I connect with the router 1 is S1/0. So either I can use S1/0, or I can use the IP address of the port. So I can use IP address this time, 12.0.0.2. Okay, and hit on enter after that.
Okay.
So now the route is created. Okay, let's see whether the route is created or not. I go to exit and show IP route to check the routing table. Enter it. See, S means static. Okay, and
Static.
we can create
Mm-hmm.
the route. So via 11, if I need to reach 11, so I need to exit with 12.0.0.2.
So.
Yeah. And that 1/0 is the port, or
Is the port. We can define the port also. By
yeah.
default, you can say that in the directly connected networks, it defines the ports. Okay, so like you can do
Yeah.
like this also. Like
Mm-hmm.
if we have another method too. So like imagine that if I go for that, so I go to config T. If I need to first delete this route now, I want to delete this route first. So how we can delete the route? Just simple write no over there. No IP route 10.0.0.0 and 255, sorry, 11.0.0, 255.0.0.0, and the last is 12.0.0.2. I delete the route. Now the route is deleted. Let's check once. Go for show IP route. We can say that the route is deleted. Now they're not showing me 11 route over there. Okay. Now why I delete
Yeah.
this route? Now I use the port number. How we can go for the port number is config T IP root. The destination is 1011. Mask is 255.0.0.0. And the port number we are using right now is S1 slash
Zero.
0. This is the port number, right?
Yeah.
My destination port number is this. Okay, so means the next hope port number is this. Enter it. Now the route is created. Now if you can see that, go for show IP route. So see, this time it shows me the port number.
Mhm.
So it's up to me. Either I can use port number, or either I can use the port address. Clear?
Yeah.
Now we
Okay.
go for router number 2 now, and same I can create the routes. Okay, from router number 2 also, because router 2 only know 11 and 12 route. It doesn't know 10 route, as you can see that. Okay,
Mhm.
so what I need to do, I go to config t. Now what's the command first? IP.
IP config.
No, IP route. The
IP
command
route, sorry.
IP route. Now we can define the destination. Now my destination address is what?
10.0.0.0.
Okay, the
255.
destination network, and then 255.0.0.0. And
Yeah.
now we need to define the next hope address. So for router 2, who is the next hope? Router 1, right?
Yeah.
And then the hope
5001.
address is this 12.0.0.1, or I can define the port number. So we can define the port number is S1 slash 0 and enter it.
Yeah.
Understand, Denisa? Right?
Yes.
Now you go for show IP route. Enter it. You can see that. Now the 10 route is created successfully, and it's created with S. S means static. I create manually this route.
Mhm.
Now we'll check the pinging. I go for ping. Okay, and now I need to go to the 10 network. I need to ping with the 10. So at 10.0.0.1, I go to the loopback one. Okay, the ping 10.0.0.1 and enter it. They're showing me 100% success rate now. Why? Because I have a route now. You can check the trace route command also, where it goes. We go for traceroute command. We have a traceroute command also. 10.0.0. I go to 10.0.0.1. Enter it. So trace TRACERT. The spelling is okay.
This route.
Trace route, maybe your trace route is command is there.
Yeah.
Trace route command, okay.
Mhm.
10.0.0.1 and enter it. So they're showing me it tracing. So you can say that okay, it takes via 11.0.0.1. So as you can see that. So if I need to reach 10.0.1, so it go via 11.0.0.1, because my next hope address is always 11.0.0.1. Okay, it takes
Yeah.
36 milliseconds to go to reach the 10.0.0.1. Understood? Clear?
Yeah.
Yes.
So this is the basic concept of static routing we can talk about. So if you see the administrative distance, so I don't think so in static routing we can see that show IP protocols, maybe the command is, but right now we don't have any protocols. Okay, so static routing, by default the static routing administrative distance is 1. Okay, by default, because we're using the static routing, there is no protocol is running, so they're not showing me the protocols. In static routing we can define the routes manually. We're not creating the routes automatically in static routing, as you already see that.
Mhm.
Okay,
Yeah.
clear?
Yes.
So I hope till now you're able to understand the basic concept of routing and static routing too, right?
Yeah.
Okay, so now let's take the 30 minutes break. Right now it's 1:25, so we'll start with 2 o'clock, 35 minutes break. Okay, fine.
Okay.
Okay, fine. Thank you. Okay, everyone is there, right? Okay, so let's go for that now. So we already talk about the basic configuration of static routing, right? Okay. So I hope both of you able to understand this till now. Now,
Yeah.
okay. Now let me take another router over here, and we'll attach the slots also. Okay. Now I can connect these two routers also, router 2, router 3. So I go for CL 1 by 1 2, router 3 1 by 0. Okay, I connect like this. So it is 1 by 1, and over there is 1 by 0. And we can use the loopback also over there. So we'll use loopback 0. And over there, 10, 11, 12 we already use. So over there we can use 13,
Yeah.
13, and we'll go for 14 over there. That is 14.0.0.1, and we have 14.0.0.2. Okay, here it is 14.0.0.2. Here it is 14.0.0.1. Okay, now I first configure the router 3 first. Okay, so we need to start the router 3 first. We'll go to start router, start. Okay, router 3 started. Now I go to right click and go for console. So I just go for change settings, appearance, change font 14 I can use. Okay. Okay, so let's start with the router 3 configurations. Okay, so I go for config, sorry, enable config T. Config T is there. Go for interface, S1/0. Okay, and go for IP address 14.0.0.2, 255.0.0.0. Go for no, shutdown. Okay, and then we can go for the interfaces also. So go for loopback, interface loopback 0, and go for IP address 13.0.0.13.0.0.1, 255.0.0. Go for no, shutdown. Okay, go for show IP interface brief. So as you can see that we can configure serial interface and loopback 2 in our router 3. And router 1 also, router 2 also we need to configure this port, because we not still configure this port. Okay, so in router 2 we'll go for config T and go for interface S1/1, second interface, second serial interface, which just connect with the router 3. So you go for IP address 13.0.0, sorry, 14.0.0.1, 2.5.0.0. Go for no, shutdown. Okay, go for show IP interface brief. So as you can say that I configured for second serial interface also. Okay, now we already did static routing between router 1 and router 2, right? Okay,
Yeah.
so if I'll show over there, so go for show IP route over there. So as you can say that router 2, if I see the router 2, so router 2 reads only maintain only 10, 11, 12, and 14 routes. Okay, there is no 13 routes mentioned in the router 2. So it means if I ping with the 13, so he's not able to forward the packet on 13 network, because he doesn't know the route on 13 network. Okay, and if I go to the router 1 also, okay, router 1, and over there also, if I go for show IP route, so over there also, see, now router 1 is only knows 10, 11, and 12. He's not learn 14 and 13. Okay, so 10, 11, 12 router know 10, 11, 12. But if I trying to ping with 13 and 14, so router doesn't have a route of 13 and 14 networks. Okay, so now we need to create first 13 and 14 networks on router 1. Okay, so let's start the configuration. So just try to understand is there that if I am in router 1, so I need to create the route. My destination is 14. So what is the next hop address for 14 network? If I need to reach 14 network, so what is the next hop address for me?
The router 2.
Right now I'm in
So
router.
12.
Yeah,
Oh,
right now I'm in router 1, okay, and I need to reach over there. I need to reach 14 network. So what is my next hop address is?
12.0.0.2.
Yeah, so I go over there. So router 2 is my next hop, and the next hop address is 12.0.0.2.
Yeah.
Understand?
Yeah.
Denise, all right. Okay, so
Yes,
we'll go
yes.
for okay, so we'll go for like this. So I'll go for config T over there, config T, and go for IP root, okay, and go for 14.0.0.0 to 5.0.0, and the next hop address is 12.0.0.2, or instead of this I can define the next hop number also, port number also, enter it. So now as you can see that if I go to show IP root, so now this router knows where I can need to reach the 14. So he know what's the
Mhm.
route to reach the 14. Now I need to reach the 13. So in that case, what we have now, I need to create. Now I need to create the route from 13. Now I need to reach 13 network from router 1. So who is the next top address?
The same.
Same 13.0.0.0 255.0.0.0. Okay, so next top address is same because I need to go there to reach 13 as well. Okay, fine. So I need to cross. I need to cross the router 2. So router 2 address is 12.0.0.2 and hit on enter as you can see that. So I go to show IP route. So you can see that I configured every route, every 10, 11, 12, 13, 14, every route I configured on the router 1. So router 1 knows all the 5 routes, all the 5 network routes. So if I try to ping with router with 14, as you can see that 14.0.0.2, so he's able to ping because he knows the route now. Okay. Now why is not pinging? Any guesses? Router 1 knows all the routes. Okay, it's okay. But router 2 and router 3 doesn't know na all the routes.
So that's why we don't have a reply.
Yeah, that's what is the issue. Like if I showing you, if I go to the router 2 now, so what router 2 knows, as you can see that if I go to C, so he is able to knows only 10, 11, 12, 14. He's not able to know 13 router, 13 route. Okay, and if I go to router 3, so router 3 doesn't know any route right now. He knows only 14 and 13 routes. Show IP route. So as you can see that 13 and 14, he knows only 13 and 14. He doesn't know about means 10, 11, 12. So when I ping with router 3, as you can see that, right. If I go to ping with router 1 to router 3, so router 3 is not replying. Why? Because router doesn't know the 12 network right now. That's why he's not able to, that's why he's not able to reply in that case. Okay, fine. So we need to first create all the routes and all the routers. So we'll go for first router 2. Okay, so router 2 knows 10, 11, 12, and 14. Router needs to learn about 13 network routes. So how we can go for that? I go to config T. Now I need to reach 13 from router 2. So what is the next hop address?
14.0.0.2.
Okay, the next hop address is 14.0.0.2. So like this. Okay, so I create the route. So if I go for show IP route, enter it. So as you can see that 10, 30, 11, 12, 13, 14, all the routes are configured in the router 2. Okay, now I'll go to router 3 now.
I have a question.
Yeah.
If we want to define the route based on the router 3 port,
Okay.
how would router 2 know that serial 1/0 is to router 3 or to router 1?
So he knows
Because
he checks the IP addresses. Now, like imagine that if he sees the CL10, his IP address of CL10 is 12.0.0.2. Okay.
yeah,
So if I need to send the destination, if I need to send packets from router 1 to router 2 to router 3, like imagine in packet we have a destination address 2, no? Right?
yeah,
Okay. So if I check the destination address, so what happens in that case? If I need to check the destination address, so what router 2 sees? Router 2 sees that, okay, this packet is goes to 14 network. But if he sees their S1/0, so he checks that, okay, my one is 12.0.2. So it means that we need to forward them to this port so that he is able to go for 14.0.0.2. Okay, in that case, he sees the addresses, he sees the IP addresses also, because every packet we have a destination address also, because as I already told you that your router works on IP address. Okay, it's not work on MAC
Hmm.
addresses and port numbers. Okay, by default it works on IP address. So if he works on IP address, so he knows the routing table that if I need to reach 14, so where I need to exit, right?
I see. Yeah.
Okay, so like
So so the command in which we use the port would also work on router 2. Yeah.
yeah, definitely. Like if you see that na, in routing table, if you see the router 2 routing table, so we have two ports, two CL1 ports, CL1/0, which is connect with the 12, and we have a CL1/0, which is connect with the 10. Okay, and we have a
Yeah.
CL/1/1 is connect with the 14. So I think it's wrong. We need to correct over there. Okay, yes, it's connect with the 14. Like you can see that,
Yeah.
because 14 is a directly connected network on the router 2, so it always goes to CL1/1, as you can see that.
Yeah.
Okay,
And
so that's what we have. So with the help of CL cables, with the help of CL ports, it sees the network address too. It shows the
yeah.
corresponding, it mapped CL table with a CL port with network address too. So he checks both things. Now he checks the protocol, a port as well as the IP address too. At which network I need to forward the packet. Okay, once router 2 sends any packet to router number 3, so first router 2 checks the destination, where I need to send this packet, on which network, whether he sends the 13 network or whether he sends the 14 network. Understood?
Yeah.
So
Yeah.
as per that, he checks the ports, where I need to send, where I need to go with the which port. Okay, so he sees both the thing, port as well as IP address too. So now if you go for router 3, now we need to create the routes. As you can see that, so it's easy. So 13 and 14 is already created because a directly connected network. I need to create 12, 11, and 10 routes. Okay, so first I go for 12 route. So I go for config T and go for IP route. Now we need to go for 12. So 12.0.0.0, 255.0.0.0. Now the destination, the next hop address. So what's the next hop address? If I need to reach 12, so what is the next hop address is?
14.0.0.1 or
001.
S1
No, 001 always.
dash 1.
Okay, or we can go for S1/1, or we can go for IP address. So we can go for IP address 14.0.0.1. You can see that. Enter it. So
Yeah.
one is created. Now I go to IP route second. Second, I need to create 11 route also. So go for 11.0.0.0, 255.0.0.0. Now, which is the port I need to require? Which is the IP address over this to reach 11?
The same.
The same 14.0.0.1, because we have only one exit phase. Means we have only one next hope, and we have only one next hop interface. Now you go for IP route 10. So for 10 also, where I need to reach with 14/0.0.1. Okay,
Yeah.
so for every network for 12, 11, and 10, we need to cross this. We need to reach this port, the next hope address or next hope port. Okay, enter it. Now we can go for that. If you see, show IP route, so all the routes are created in the router 3, as you can see that. Now if I trying to ping with router 3 to loop back 10. Okay, so I go for ping 10.0.0.1, enter it, so they're showing me reply. As you can see that I'm successfully go there. Okay, if I go for trace route and go for 10.0.0.1, so where he goes first, he goes to 14.0.0.1, and after that he goes to 12.0.0.1. So they have two you can say that two ports where he exit. Number one with 14.0.0.1, the next stop of the router 3, and then he goes via 12.0.1 with the next stop of the router 2. Okay, like this. Okay,
Yeah.
and then he can reach the 10.0.0.1, and so that. So with the help of trace route command, we can trace the route also where he goes. Means what the path he chooses over there. Okay,
Mhm.
Fine. So this
Yeah.
is what we have a static routing. So it's a very simple step of static routing. Static routing. Just a wait, huh? Just a minute. Okay, so able to understand everyone right now, right?
Yeah.
Yeah.
Now in static routing, we have need to understand that the one thing also.
Can you change the last route on router 2 and
Which one? Which one?
the one to, I don't know, on router 2? What was the
On
last one that we did?
on router two.
Yeah, on router 2.
The last one we did the 14 network, right? Here it is 13 network.
Yeah.
You can check
Can
it
you delete it and create it
with port. With
with
port.
the port? Yeah.
Okay, you just check. You want to see which port it goes for that, right?
Yeah. I just want to
Okay.
make it very clear.
No. Okay. No IP route and go for 13.0.0.0 2.5.0.0 and for 13 where we are we need to reach for 14.0.0.2.
14. Yeah.
Okay.
Mhm.
Now go to IP route 14 sorry 13.0.0.0 2.5.0.0 and go for S1/0, right?
Yeah.
Okay.
Let's see.
Okay. Now.
Show IP route. In IP route, they're showing you which route he. So now you can see that it goes via
Yeah.
serial 0/1.
Mhm.
Good.
Okay, fine.
Now it's better. Yeah.
Yeah, so you can choose the port as well as you can choose the IP address. It's up to you. Okay, we can choose both the things. Now we'll go for this one. So this is second practical in static routing is we need to understand is disclose this subject. We need to understand is load balancing. It's a very good topic in static routes. So like if you go for that, we have a static routing as you can see that. So we have a load balancing too. So what is the load balancing over there? Like I have a two routers like this. Okay. Now what the meaning of load balancing is when I use for load balancing means that load balancing is used to use the both path. How we can go for both path? Like imagine that if I have two best path to reach one destination, like imagine I can put two cables over there. Okay, I have two cables right now. I can connect two cables. Okay, and over there I'm using imagine 10 network, and over there I'm using imagine 11 network like this. Okay, fine. Now I need now in that we have a loopback also. So loopback is LO. You can differentiate loopback with L0. You can see that over there I'm using 12.0.0, and on the other side we are using the loopback like 13.0.0. Okay, fine. Now what happens now imagine that router one wants to send now these routers these right now I'm using the static routing. So static routing chooses the best one with the help of you can say that with the help of the next hop address and all those stuffs. Okay, so now you can say that these both bandwidth has the same means these both wire have the same bandwidth. We can use 1 Mbps over there also. Okay, and we have 1 Mbps over there also. Okay, and you can say that we are using the same bandwidth. We have there is no bandwidth, no delay. Means both have the same bandwidth and there is no delay on both the paths. Okay. Now the condition is now router one wants to forward some packet to the router two. So now he reach on the router two now. Now how he choose that who is the best path because both the bandwidth and both the wires has same speed. Okay, same delay, same hop counts. We have if we talk about the hop counts of same hop count, same cost, same delay, same bandwidth. Okay, so in that case if I have so what happens at router one chooses that both the path is the best path for me. Understood? By default router
Yeah.
one will do he chooses that both the path is the best path for me. Okay,
Mhm.
and he's starting doing load balancing in that case. Now, what is the meaning of load balancing is there? Like imagine if I need to send 4 packets, okay, in one data, I need to send 4 packets. Imagine 4 packets. Okay. So what he do? What router one do? He forward. You can say that 2 packets on the first route, the first link, the first cable, and he uses the third and fourth packet to second cable. That means half of the data sends to first cable and half of the data sends to second cable, like this.
Mhm.
That's what we have a load balancing. So where we can use load balancing if we have a two best path. It means on where we have, you can see that where your router is not able to choose the best path. Who is the best path, and he has more than two paths who becoming a best path. So in that case, what router does in that case load balancing. So in load balancing, what he do? He send half of the data to first link and half of the data to second link. Like imagine first packet goes to over there, second packet goes to second link, third packet goes to third link, first link, then again fourth packet goes to second link, then again fifth packet goes to first link, then again sixth packet goes to second link, like this. This is what we have a load balancing. Understood? So
Yeah.
we
Yes.
can we can did load balancing in routing protocols also, or we can do load balancing, or we can use load balancing in static routing too. Remember these things. Okay, fine. So how we can do load balancing, as you can say that. So in this kind of scenario, what I do, I can use connect one cable with this. Wait. Okay, I can use one cable, as you can say that, connect one cable router one to router two. Imagine like this.
Mhm.
Okay.
Yeah.
So this is
Okay.
my second cable, S1/1 and S/2/2. Okay, and okay, so it's a down one. Sorry, the first one is a first cable, second one is a second cable, like this.
Mhm.
Okay. Now this is the second port we have over there, and the second port over there. Okay, and we can use the IP addresses also. So there is a separate network because we have another cable. We'll go for 15.0.0.0. Okay, so one is there. Here we can use one this side, and this side we can use 15.0.0.2,
Mhm.
like this. Now if router 1 wants to sends the data packet to router 2, so it has two best route, right? It go via 12 and it go via 15 also. Okay, so let's see, I'll showing you how we can go for that. Let's first configure this link IP addresses, this port IP addresses, which I connect. I'm sorry. Okay, which I connect these things. Okay, so let's go for that. So I go to router one first, and I to configure the IP addresses on the port. And go for config t interface s1/1 IP address 15.0.0.1 to 5.0.0, and then go for exit. Okay, and go for exit again. Go for show IP interface brief. So as you can say that 15 is set. Okay, no
Mhm.
shut.
No shot. Yeah.
No shut is missing. That's why it's not up. So go for commenting interface s1/1. Go for no shutdown. Now it's shows me it's up. Show IP interface brief. So as you can see that now it's up. So
Yeah.
remember that you need to run no shut command also in every interfaces after configuring the IP address. So now go to router 2 now. Over there also I need to set it. So config t and go for interface s1/2, go for IP address 15.0.0.2 5.0.0, and go for no shutdown. Okay, show IP interface brief. So over there also this setting is there.
Mhm.
So once I try to ping whether it's a connectivity is over there or not, so ping 15.0.0.1 success rate is 100%. It's okay, it's connected. I go to router 1 and check with the ping again 15.0.0.2, so it's connected. Okay, so it means that
Mhm.
my connectivity is there. Now I need to, so whether we can create the routing or not, I don't want to create the routing because this is the directly connected network on router 1 also. So router 1, maybe the route is automatically created because it's a directly connect with the router 1. So go for show IP root, enter it. So as you can see that 15 root is automatically there because it's a directly connected network on router 1. Okay, on router
Yeah.
2 also show IP root, you can say that, so it's directly connected, so it's there. I need to create the root on router 3 because router 3, this network is not directly connected, right?
Yeah.
So I go to router 3 and go for show IP root once to check it. So for 15 is not there, so I need to configure 15 root. Go to IP root 15.0, I'm sorry, 15.0.0.0 255.0.0. Now the next hop address is to reach 15 is right,
One.
right. Okay,
One.
now go for show IP root. So 15 network is created. So I just ping with 15, 15.0.0.1. So I'm able to reach it. It's okay, done. So everything is fine now. Okay. So now we talk about the load balancing. So as you can see that if I see there in the static routes, sorry, in the routing table, if I go to IP, so now there is a load balancing. As you can see that. Have you seen it? Like, see, if I need to reach from router 1, if I need to reach 13 network or 14 network, or you can say that, yeah, if I need to reach 13 and 14 network. Okay, so we have two routes, as you can say that 13.0.0.0 to if I need to reach 12, if I need to reach 12. Okay, so we can able to reach with 13.0.0.2. Okay, 13 network. If I need to reach 13 network, so I need to go there via there, and if I need to reach 14 network, it's go via again 12.0.0.2.
Mhm.
So with the help of the same, as you can say that same device, okay, it uses go for that. Okay,
Okay.
fine. Now I'll go to the router 2 in that case. Now I'll go to the router 2 also. Show IP route. So over there they're showing me the ports. Okay, in router 2, just wait. In order to also 10 network, we need to see uh, the the routing. So let's see. We'll go for ping. Just one start with the. I just go for ping with 10 network. 10 dot. Trace route. Go for trace route 10.0.0.1. I need to reach 10.0.1. So with the help of 12.0.0.1, he's able to reach. Okay. And if I go to router 1 and try to go for trace route, go for reach where I need to reach 11.0.0.1. Okay, it uses the first only right now still. It
So
uses,
we need to add the route also through
yeah, yeah,
15.
right. We need to add the route also too. That's why after that it's go started with the things, because he directly created the route, as you can say it's directly connected. Okay, but he takes only right now the first route. He's not taking the second route in that case, as you can say that. If I try to ping, if I go like, imagine that if I right now router 1 and try to go to 14 network. If I check once trace route with 14 network 14.0.0.1. so over there, see, over there still they see they go to 11.0.0.2. So it's taking the first route only. It's not taking the second route. Okay, right. So for that, what I need to do? Okay. Let's see. So we need to get the two routes, as you can say that. So I'll go for like this. So I go for config t, go for IP route. Okay, IP route. If I need to reach over there, you can say that 14 255.0.0. So I need to reach with 15.0.0.2 as well, right?
Yeah.
Sorry, yeah, 2 as well. Okay, enter it. Now again, I need to mention another route for 13 as well. I need to go for same. Okay, and
Yeah.
for 11 as well, I need to go for same. I need to create the routes with this port as well. Okay, clear? Okay,
Yeah.
Yeah.
in router 1 and in router 2 also, I need to go like this. So I go to router 2 now, go for config t, go for IP route, and go for reach with the 10
10 and 12.
255.0, and we'll go for with 12.0.0.1. Okay, and for 12 also need to reach the same. Okay, fine. And 15 also, right? We have a
15. Yeah.
15 route also. 15 also need to reach the same. Okay, so let's see. Show IP route. So now you can see that we have the two routes, as you can see that. Okay, so you can see that it goes via 10 with the help of this also. So now let's see if I try to trace route now trace route with 10.0.0.0.1. Okay, so it's choose now 12.0.0.1 also. In that case 12.0 up 1, but it's still not taking the 15 one, right? So okay, now in that case, what happens? Like if this route is down, so they give you the redundancy only. They not give you the load balancing properly in the static routing. Like if I go there, ping, I'll go for 14.0.0.1 and enter it. Okay, go for trace route 14.0.0.1. So now they're showing you. See that we have two routes. It goes to 15 as well, and it goes to 12 as well. It takes some time. Now I start doing these things. Understood? Okay. So if I need to reach 14 network, so what they're showing me, we have two routes. Either I can go with the help of 12.0.0.2 this port, or either I can go for with the help of 15.0.0.2 this port. So we have two routes. This is what we have a load balancing, as you can see that.
And the third one.
Third one is also it go for if you go for router
No,
one.
no.
Yeah,
In that trace route.
yeah. The trace
So
route on third
it
one.
shows that we have two routes, and after that, why do
Yeah,
we have again 12?
yeah. So like if I go to reach 13, right? 13
No, no,
dot
no.
over there on the router 3, right?
On the trace route that is already there.
Yeah.
Why do we have the third line?
Third
So
line again.
first two are the two
Yeah,
available routes,
yeah,
and the
yeah, yeah.
third one is the one that he chose.
He chose again. You can say that because by default it was work on the active one, as you can say that the first link. Okay, you can say that like this. So means they're showing you only the two. See now they now it sends the packet to 15 one, as you can see that. Previously
Yeah,
I go for trace route, so go they starts with the 12.2 and now they start with the 15.2. Now again if I go for trace route, so they go for 12.2. Now again I go for the trace route, they go for 15.2. As you can see that.
yeah.
One by
Okay,
one it syncs that like this. So it's for load balancing we have. Okay, fine.
understood.
So
Yeah.
that's why we have for that. So one packet it sends the one thing like this. Okay. So this is what we have a static routing. What we can see till now. Okay.
Yeah.
Now if you go for dynamic routing, so in dynamic routing, what we have in dynamic routing, so we'll start with the number one protocol is known as RIP. Okay. Let's learn first about the RIP and then we can start with the dynamic routing. Okay, so we'll minimize this one. Now let's start with the RIP. Okay, so the first protocol which we talk about is known as a RIP protocol. Okay, so RIP is the first protocol we talk about. So RIP is known as routing information protocol. We talk about the dynamic routing now. Dynamic routing. So in dynamic routing, the first protocol is RIP version 1. Okay, so we talk about the version 1. Okay, so version 1 this protocol, as you can say that it work on which category? It's work on interior gateway protocol category, means IGP. Okay, RIP version 1 works on which category? Interior gateway routing protocol category. Number one. Okay, interior gateway protocol, interior routing protocol, which we talk about. Remember? Okay,
Yeah.
fine. So number second, it works on number two, distance vector category also. Distance vector. Okay, fine. Now we talk about the RIP. So RIP uses what metrics? So it works in distance vector. It means that it works on hop count. Okay, remember hop count. Okay, so it is used hop
Yep.
count to you can say that it uses hop count to go for okay, it uses hop count to choose the best path. Okay, number fourth point you need to understand is that number fourth point, the AD value of this router is this is 120. Okay, which you already talked about. Okay, and number fifth, sorry, number fifth, hop count limit is 15. 16 is unreachable. 16 is unreachable. Okay, so it means that RIP crosses only 15 devices, not more than that. Okay, so if you have 16 routers, imagine start with R1 to R16. So he just sent the data till R15. 16 for 16 R for RIP is unreachable. So we're not able to use no more than 15 devices in one path, as you can see that. Understood? Okay.
Yeah.
Yeah.
So like this, we need only 15 devices. Okay. Now we talk about the timers. So we have a RIP timers too. Okay. RIP timers. So timers we talk about, it has number one timer is known as the update timer. So update timer, you can say that 30 seconds. So every 30 seconds, what RIP do? RIP update their routing table every 30 seconds, as you can say that. Okay, understood. Every 30 seconds, RIP updates the routing table. Okay.
Yep.
Now we have the second timer is known as. Now, if we understand these things, the timers also in up in up means you can say that in the later part. First, you need to understand is that RIP timers. So we need to understand the first timer is known as update timers. Okay, update timer is always used for updating the routing table. So RIP always update the routing table with the help of 30 seconds. Means after 30 seconds, what happens? Every 30 seconds, RIP update the routing table to their neighbor router. Okay, so like imagine that if I have a two routers connected with each other like this is a router 1, router 2, and router 3. Okay, so here is the router 1. Router 1 has a routing table, router 2 also have a routing table, and router 3 also have a routing table. So what happens, imagine that if router 1 connects with the router 2 and router 3, and we are using RIP protocol to all the routers. Over there also we are using the RIP version 1, RIP version 2, and we have a RIP version 3. Sorry, I'm using over the version 1 also, and over there also I'm using the version 1, not version 2. I'm using the version 1 over there. Okay,
Yeah.
version 1. Okay, now if I need to, so what happens in every 30 seconds, like if this router has a 5 networks with their routing table, like we can say we already discussed that in that router 1 we have how many routing table, in the routing table we have 6 networks, 10, 11, 12, 13, 14, 15. Okay, so he sent his complete routing table to router 2 every 30 seconds. Okay, and also router 2 also sends his complete table to router 1 and router 3 also to every 30 seconds. As the same thing, router 3 also sends their complete table to router 2, sorry, and router 3 also, like this. Okay, so this is what a router RIP is doing. RIP is working. So as you can see that RIP always send their complete routing table, okay, for every 30 seconds, between the routers, between the RIP routers, as you can see that.
Only to the neighbor routers
Only
or
to the neighbor
to
routers. Only to the neighbor
the
routers.
neighbor. Okay.
Because we directly connect with the neighbor routers, right? Okay.
Yeah.
So only the neighbor routers, if you talk about. Only the neighbor routers, not anything, not anyone else. Okay.
Yeah.
Fine. So like this is the RIP update timers we have. Update timer is a 30-second timer. We can change this timer too also. Okay. It doesn't mean that we can change, not we're not able to change these timings. We can change this timing too also.
Yeah.
Okay. Now next timer is known as, you can say that, second is known as the hold on timer. Sorry, invalid timer first. Invalid timer. Now invalid timer is taking 180 seconds. Okay. Invalid timer is 180 second. Okay. And then number third is hold on timer. Hold down timer. It's in again 180 seconds. Okay. The timing is 180 seconds. And the last one we have a flush timer. It's in 240 seconds. Okay, fine. So these are the timers we have. Now, what is the meaning of invalid timer? You can say that invalid timer is that, like, imagine in router one, I have, imagine we are using the, it working, it has 5 routes. Route is 10.0.0, 11.0.0, 12.0.0, 13.0.0, and 14.0.0. Imagine we have five routes in the our RIP1 router one routing table. Okay, same we are in, you can say that, routing 2 routing table also, a router 3 routing table also, like this. Okay, understand. Now what happens in that case, like imagine that now after 180 seconds, okay, imagine that if router 1 sees that there is no update on network, on 10 network, there is no update, you can say that, on 10 network. Okay, so after 180 seconds, it waits till after 180 seconds, still this network is not updated, he invalid this network, as you can say that. Invalid means he thinks that this network is not working, as you can say that. Okay, he thinks that the network is not working, and he said this network is invalid. Okay, fine. Now he wait again, next 180 seconds again for this for this network to update. Again 180 seconds, next 180 seconds, as you can say that. Okay, so till next 180 seconds, it hold down this route, as you can say that. Okay, it's he hold down this route, he's not lead the he's not lead this network till now. Okay, and he waits how many seconds, 180 seconds, then again 180 seconds, as you can see that. So total it waits approx 6 minutes, 6.5 minutes, as you can see that, till now, to waiting for this update, this network update. Then again he again this router wait 240 seconds, another 240 seconds, to delete this route permanently on the routing table. If you imagine total how many minutes over there, if you calculate the minutes, total the minute is, you can say that, 10 minutes and 30 seconds it takes. In short, it takes 10 minutes 30 seconds to delete a particular route, if the route is not available or if the route is not updated, as you can see that. It takes how many minutes? It takes 10 minutes 30 seconds, if we talk about the by default timings.
Yeah.
Okay, if you want to change the timings, you can change the timings too, but it's a too long time, as you can see that. Okay, it's a very long time to delete the route, to delete a particular route. Why it's long time? Because imagine that if a router one takes 10 minutes 30 seconds to delete the routes. So imagine that if I have so many PCs are there with me, and he regularly send the packet to this particular route, this particular network. So see, so many packets are there on the router in that case within 10 minutes. Okay, so that's why it takes too much time, you can say that. The by default timing is too much, as you can see that, as compared to delete a particular to delete a particular interface, or to delete a particular route. Okay, fine.
Yeah.
So like this, we can your router works. These are the timers of the routers. Means RIP version 1. Okay. Now next characteristics we need to learn, and this is like if you go for seventh one. So I already told you it updates the full table every time. Okay, it updates the full table every time. Like imagine if any changes in the router one. Now previously, imagine that previously I work on we have a, like imagine that previously I have a, like this. So imagine that previously I have a 5 networks. Now one network is increasing in this router. Like imagine it's go for 15 dot, wait, like imagine that the now is 15.0.0.0 is there. So new network is there. Imagine on the router I attached with the router one. So instead of giving the updates to 15 only, he sends again their complete routing table again. Okay, he not send only the 15 updates. Like it means that you have a 15 network, you have 15 new update only, so you can send the 15 network only to all to their router 2. No, but what he do, he sends the complete routing table every time to router 2. Now router 2 checks what is new in this. So he checks that okay, 15 network is new. So the router 2, you can say that add 15 network to their database also. And again, router 2 also sends their full table to router 3, and router 3 also add 15 network to their database, as you can say like this. Okay, so if every time router sends their full routing table, so what happens in that case, there is a lots of you can say the data means data traffic is there. Okay, like imagine right now I have only 6 networks. Imagine I have 60 networks in my network. I'm using 60 networks. So what happens in that case? Imagine if my table is that much long. Okay, so in that case we're not able to go for that. Okay, so that's why this is the drawback in RIP. You can say that it sends always a complete routing table every time. Okay, understand this, right? So the seventh one, RIP always sends their complete routing table. Okay.
Yeah.
Now eighth one, it works on class. It works on classful IP address. Now, what is the meaning of classful IP addresses? Classful IP addresses means the IP addresses which we not subnetted, which we not break, or not. I'm not using. You can say that like I already talk about the IP addresses that with the help of subnetting we can divide the network. Okay, so if I using the subnetting and if I divide the network, so in that case we are using the classless IP addresses. The classless IP addresses is that IP addresses which we did subnetting on the particular network, on the IP addresses. Classful IP addresses is the default IP addresses which we use, like which we use over there. Right now we don't need any subnetting IP address over there. I'm using the by default IP addresses over there. Okay, that's what we have a classful. So RIP, you can say that always use classful IP addresses. Okay, it not support subnetting, as you can say that subnetting. He not support subnetting in that case. Understood? Okay. Now the 10th one, it uses the algorithm. You can say that it uses the one algorithm. Algorithm name is Bellman-Ford. There is the algorithm, as you can say that. There is a one person named Bellman who you can say that launched this RIP protocol. Okay, so that's why you can go for that Bellman-Ford algorithm is there. There is one algorithm is running on the background when your RIP is working. Okay, so every protocol has the algorithm, as you can see that. Okay, to you chooses the best one with the help of matrix. So how matrix work with the help of how matrix works? Matrix works on a particular algorithm. So distance vector protocols works on Bellman fold algorithm, as you can see that. Okay, and it works always on broadcast communication. Broadcast communication. Broadcast. It always works on broadcast. Like this. These are the 11 points we need to understand with RIP version 1. Okay, fine.
Yeah.
So understand Danisa also, right?
Can you hear me?
Yeah, I'm hearing you. Now I'm
Yeah.
hearing you. Okay,
Yeah, I understand.
okay, fine. So this is what we have. Now, next, if we talk about the comparison of RIP version 2 also, we have RIP version 2 also. If we talk about the RIP version 2, so in RIP version 2, what we need to do, we need to understand is that everything is same in RIP version 2. The timers, the hop count limits, AD values, the matrix, distance vector, IJP, everything is fine. What's the changes in RIP version 2? I'll let you know. What's the changes is in RIP version 2, number one, we can use classless IP address. It means it supports networking, subnetting, as you can see that. Supports subnetting. Okay. Number third, you can say that it works on multicast, not broadcast. As you can see that RIP version 1 working on broadcast, but RIP version 2 working on multicast. It uses 224.0.0.9 IP address. When it starts working, it works on 224.0.0.9. So it always works on multicast. Okay, fine.
Mhm.
The next one we need to go for that. We can use authentication also. Okay, authentication also in RIP version 2. Authentication. So we can use the authentication 2 also in RIP version 2. Okay, so there is no concept of authentication in RIP version 1, but we have authentication concepts in RIP version 2 as well. So we can use the concept of RIP version 2 as authentication. Okay, fine, like this. So we have this kind of differences between the RIP version 1 and RIP version 2 in that case. Okay, so RIP version 2 has three differences. It is supporting subnetting, it supports classless IP address. Okay, and it works on multicast with the IP address of multicast using is 224.0.0.9, and it uses authentication too. Okay, fine.
Yeah.
So this is what we have. So let's configure RIP version 1 first of the routers, and then we can go for RIP version 2. So for RIP version 1, what I need to do first, I need to remove, not remove, I need to first go for no IP root in that case. So whatever routes we can create, we need to go for no IP root on router 1. No IP route over there. We have the connection between router 1. It's 10 and 15 is there. We have to go for 14.0.0, 255.0.0, for 12.0.0.2. No IP route, same 15.0.0.2. Then no IP route 13. Then no IP route 13 with 12.0.0.2. Okay, and we have a 11 also. So go for 11 also. No matching route is deleted. Okay, go for 15. I think 15 is there. Okay, fine. So let's check once. Show IP route. Okay, one static route is there also. Still is there 11.1. So go for config T. No IP route 11.0.0.0 goes to 255.0.0, 12.0.0. No matching route is related. Okay, if I go to 15, okay, it's deleted already, for I is showing you. Okay, serial port S1/0. Okay, so that route I create with the port, so that's why they're showing me. Okay, so I'll go for show IP route. So now you can see that all the routes are removed from route 1. Okay, we only it shows the directly connected routes only. Okay, now I'll go for router 2, and I need to remove all the routes over there also. So config T, go for no IP route. Right now in router 2, so 12, 15, and 14 is directly connected. 11 is also 10, 12, 13, 14. So okay, so we'll start with the 10.0.0, 2.5.0.0, and okay, we'll go for 10. So with it's with CL1/0, and with this it's created with 12.0.0.12. Okay, then we can go for no IP route 12 also. Okay, it's connect with okay, and we need to go for 14 also. Okay, 14 is already there. 13.
So now we are removing all the existing routes.
Yeah, because you're already existing with this. Okay, let's see. 13 network is also there only with the help of CL port. Okay, we'll go for config T. Go for no IP route. Okay, and go for 13.0.0, 255.0.0, and go for CLs 1/. That's it. Go for show IP route and enter. So all the routes are deleted, which is where we have worked with statically. Okay, it's all the routes are deleted already. Okay, so now I go for router 3 as well. So also they have the route. For show IP route. So these are the routes we have. So I delete all these routes, this 10, 11, and 12. Okay, and 15 also. So go for config T. Go for no IP route. Go for 10.0.0, 255.0.0. Go for 14.0.0.1. Delete it. 10, 11, 12, and 15. Okay, and go for show IP route. So as you can see that now there is no route on all the routers. Okay, so what I need to do, I just go for router 1 now. First I need to remove this. I want to use this. Okay, fine. Let's go for, like, if you want to do for that, or let's see. Okay, fine. I'll go for router 1. Now I'll go for use the RIP protocol, RIP version 1. Okay, so for RIP protocol, what I need to do now in the dynamic routing, I don't want to I just want to give the directly connected networks only. Okay, if I using the RIP command, so I go for config T first, config T, and go for router, and then we define the protocol. So these are the protocol that support this router: BGP, EIGRP, ISIS, ISO, EIGRP, mobile, ODR, OSPF, RIP. So I'm going for RIP right now. Okay, so routing information protocols, I use RIP over there. Okay, now enter it. Now right now I'm in RIP, or you can say that. Now I will define the just directly connected network on router 1. So there is a 2 directly connected network on router 1, 12 and 15 and 10, 3, 10, 12 and 15, right? These 10 networks is directly connected on the router 1, right? So I
Yeah.
just define the network over there is network 10.0.0. Okay, second one is network 12.0.0, and third one is network 15.0.0. That's it. I What I need to do, I need to define just my directly connected networks only. If I do routing with the protocols. Okay, that's it. Okay, rest protocol is doing the further things. Protocol is used to create the routes automatically. Okay, in static routing we need to create the routes manually, right? But with the help of routing protocols, we don't want to create the routes manually. Routing protocol is there to create the routes automatically, as per their means, as per their mechanism, as per their metrics. Okay, so now if I
And now the IP routing table is changed after we stated those three networks.
yeah, you can say that, like I'm showing you how what is the difference impact on the routing table, you can say that.
Yeah.
Okay,
Okay.
now I'll go for router 2 now. I enable router rip also over there. So I go to config 3. So we have router 2 is connected four networks directly: 11, 15, 12, and 14, right?
Yeah.
11, 15, 12, and 14, these are the four directly connected networks on router 2. So I go for config T, go for router rip. Okay, then go for network, which one is 11.0.0. Then we have a network 12 is there. Then we have a network 14, which is directly connected, and then we have a network 15, which is directly connected, right? As you can see, that is showing you directly connected networks on routing table: 11, 12, 14, 15. So I say I go for that: 11, 12, 14, 15. That's it.
Mhm.
Okay, so I just give the information about my directly connected networks only on the router web. Okay, rest all the routes are automatically created. Okay, on the router 2. Now I go to router number 3. Same, I go for that config T. Now router 3 also connect with two networks, 13 and 14, directly, right?
Yeah.
So let's go for router 3 over there. So go for router rip, then go for network 13.0.0, and then go for network 14.0.0. That's it. So actually, if I run the protocol, so protocol is protocol run, means if I go for doing the routing with the help of protocol, so it's very easy. You consider like this. So if I go for like this, if I go for router 1, now we check the routing table. Let's see. I'm in a privilege mode. Go for show IP route. Okay, enter it. Now what type of changes you can see in the routing? See, we'll see that we have a rip over there.
Yeah.
Mhm. Yeah.
Okay, we have a rip over there, and a rip creates the routes. And now there is a load balancing, as you can see that. Okay, because if I need to reach 11, right now I'm in router 1, and if I need to reach 11, okay, so where I need to go, I have a two paths. Either I can go via 12.02, or either I can go via 15.0.02. They're showing me in the routing table, as you can see that. Understood?
Yeah.
Yes.
Okay, and they mention me the 120 120 is a AD value. This is the AD value. It's showing me 120, and this is a hope count. Hope count is 1, right? Right. If I need to reach 11, so I need to cross router 2 to reach the 11 network. Okay, so we have only one hope count between router 1 to 11. So that's why they're showing me we need to cross of one hope count. One is the hope count. One represents the hope count, and this 120 represents the AD value. Okay.
Hmm. And
Mhm.
for the 13 network,
Yeah,
we will
13 network we
have
have
two
two.
hops. Yeah.
Yeah, for 13 networks also we have two hopes. Now they're not showing me 13 networks. Let's check once. Yeah, now they're showing me the 13 networks also. So for 13 networks, we need to go to two hopes, right? Router 2
Yeah.
and router 3, right? And go for, we have AD value 120 because zip already works on AD value 120. Understood?
Yeah.
Clear?
Yeah.
Okay. Now if you go to router 2, let's see, show IP route, enter it. So you can say that, see, right now I'm in router number 2. If I need to reach on 10 network, so then we have only a load balancing is there. We have a two best path for
Mhm.
10 network, for reaching a 10 network, right?
Yeah.
Yes.
Fine. Like same if I go to router 3, show IP route. So as you can say that if I need to reach on 10, so at least we have a two networks. So they're not showing me 14.0.0, okay. But it has two hope counts, 120 is there. But we need to reach, so it should be a load balancing also over there. It's not doing the load balancing. But is able to ping with 10, 10.0.0.1, Yes, I'm able to ping with 10, but he's not doing the load balancing. So load balancing doing between router 1 and router 2 only. Router 3, it chooses which part. Okay. So if I go for 10, so how we can go for load balancing? Because we are router right now, I'm using router 3. Okay, so router 3 next hop is 14.0.0.1. So it's not, there is no load balancing over there, right? If I go for trace route 10.0.0.1 and enter it, so they're showing me the two paths, 14 and 15. Okay, 14 and 15. If I go for again for trace route, so again, so it chooses the second path, as you can see that, the best hope. Okay, fine. So this is what we have, the rip. Okay, like this we like with this, how we can create the, how we can do rip version 1. Okay, now if you want to use rip version 2, so it's a very simple way. Okay, like first I need to show that if I need to check which protocol I'm using right now on the router 1, 2, or 3. So I will go for show IP protocols and enter it. So they're showing me right now I'm using rip. Okay.
Mm-hmm.
Okay, and we have our update timers, 30 seconds. Okay, next update is 24 seconds. 180 seconds for invalid, 180 seconds for hold down, and 240 seconds for flush. Flushed. Flush after 240 seconds. Okay, so we have the settings over there. Okay, understood. Now
Yeah.
if you can use now you can say that my ports, so my interface S00/1, it uses it sends a version 1 and it receives version 1 version 2 both. Now there is a problem in that case in rip version 1. In rip version 1, like imagine that if I'm using rip version 2 on router 2, okay, and we are using rip version 1 on router 1. Okay, so what happens in that case? He is able to receive the packets with rip version 2, because you can see that in receiving side we have 1 and 2, both the versions are running, but in sending side we have only one version is running. So he's not able to send the packet, but he's able to receive the packets with version 1 and version 2, but he's not able to send the packet. He sends the packet with the rip version 1 only. Okay, fine, like this. So they're showing you the version, that which version we are using right now, sending and receiving the versions. So sending we always send, because we are using the rip version 1 right now, so we always send version 1. Okay, with the version 1 I'm sending, but we are able to receive the both, we receive the packets from both the versions, whether we have a version 1 rip and version 2 rip. Okay, fine. Now if you want to use the rip version 2 in this in the protocol, so what you want to do, the simple goes to there, config t, and this go for router rip over there, and this run one command only, version 2. That's it. Okay, now you can see that if I go to show IP protocols, so now right now I'm using, you can say that, version 2. See, receive version 2 and send version 2. Now because now it automatically goes to version 2, as you can see that. Okay, now version 1 is not running in this. Version 2 is there. If I go to router 2 also, so if I go to router 2 and just go for right over there, config t, router rip, and then go for version 2. Simple. Same I can do in the router 3 as well. Your version should be same to all the routers. Okay, so go for config t and go for router rep and then go for version 2. That's it. Okay, so now every router works on rip version 2, as you can see. If we go for show IP route, okay, so we have the same thing, everything is fine. Go for show IP protocols. So as you can say that it's using now, it's sending the version 2 and receiving the version 2 as well. Like you can say that. So like this, we can go for that. Okay, now if you want to change the timers, okay, so how we can go for change the timers? If I am number 1 router 1, go to config t, go for router rip, and I write over there timers. Now basic command is used to set the timers, as you can see that. So we need to run over the basic. The command is basic to set the timer. Okay, now question mark. Now they ask you write down the update timers over there. Okay, so by default 30 seconds, I want to go for 10 seconds for update. I want that every 10 seconds rip sends the update to other routers. Okay, now Invalid timer by default is 180 seconds. I go for 20 seconds, as you can see that. Now hold on timer, I go for 20 seconds. Now flush timer, I want to go to 30 seconds. So in short, 30, 20, 50, 70, 80 means within 80 seconds, if any network update is any root update is not there in within 80 seconds. So after 80 seconds, what happens? The root is automatically deleted. Okay. Now enter it. Now you can successfully change the timers. Now if I showing you the timers, whether it is changed or not, go to question mark. Sorry, Control Z. Go for show IP protocols. Enter it. As you can see that. Now previously they're showing me 30 seconds. Now we have 10 seconds. 10 seconds for update timers, 20 seconds for invalid one, hold on for 20, and flush is for 20, 30.
Yeah.
Understood? Okay.
Yeah.
Remember always that if you change the timers from on one router, you need to configure the same timings on every routers also.
Mhm.
If there is a
Oh,
mismatch of timing, so there is a very issue with that. You can imagine that what happens every 10 seconds, this router sends the update, but router 2 always or router 2 sends the 30 seconds because there is a it works on by default timers. But there is a mismatch timing is there, so don't go for mismatch timing between the routers. Okay, so always set the same timers on all the routers. So go for config T and go for router rep and then go for timers, then go for basic, go for 10, 20, 20, 30. That's it. 10 is for update, 20 is for invalid, then 20 is for hold down, and then 30 is for flush. Okay. Now go to same on router 3, config T, router rep, go for timers, 10, 20, 20, 30. That's it. I'm sorry, basic command I'm not running. That's why it's not checking. That's it. Now you can see that if I go for show IP protocols, so as you can say that the timing is changed now 10, 20, 30 like this. Understood?
Yeah.
yeah.
So this is
And
the
if we have different times, uh, we will get some errors or
yeah, we will have some latency issue. You can say that latency issue means your network is slow in that case. Okay,
yeah. So no
or maybe
errors, but just
yeah,
latency.
somehow they have the latency, somehow they have the traffic increasing in your network. You can say that. Okay, so like this.
Yeah.
Okay. Okay, fine. Now we can set the authentication to also in the routers. So like we can set the you can set that authentication means we can set the keys, as you can see that. We will set the keys also. Okay, keys means that we can protect our routers with the help of authentication, as you can see that. Okay, like imagine that I want to secure my routing tables. I want to secure my router, that no one is able to access my router, and like imagine that if someone is there, you can say that use his router, he attach the router with my router one. Okay, he run the router rip over there on their router, and router one sends all the updates to their router also. Okay, so I don't want to do this. I want security also on the routers, so we can use authentication in that case. Okay, so how we can do authentication? For authentication, what we can do, we need to create the keys. Okay, actually we have a key option is there in the rep. See, rep is a key option, keychain. The option is keychain. With the help of keychain, I can create the keys. Okay, so with the help of key, we can authenticate ourselves. Like imagine if router 1 sends any update to router 2, so first he matches the key. If the keys matches, then he able to send the updates. Otherwise he's not able to send the update to the router 2, their routing table. Understood? Okay,
Yeah.
fine. So we will
Yeah.
we will use this key concepts also in this. Okay, so let's we can create the key and we can go for this. Okay, so we have a clear text authentication also in this. Text authentication is there. So we can go for router one first, and we'll see the commands to see how we can do authentication in that case. So go to first config T, and over there we have the option keychain maybe. No, not there. Or we can go for, yeah, key option is there. Okay, Okay. Key hyphen maybe. Uh, key map is there. Okay, just wait. I need to check once. Key management is there. Key option is we need to create the keychain first. So I need to go for the okay. Let's see. We'll go for router rip maybe router rip, and then we can go for maybe the key option is there. Keychain. Oh, passive interface is there. Timers is there. Version is there. Just a minute. I need to see the command. Sometimes also I forget the command sometimes. The
So
config
we
is
need to
also
use key chain
keychain command.
or
Yes.
something like this.
Yeah. We need to use the
Try
keychain
try
command.
key.
Yeah. Just go for key space and then go for chain. Yeah.
Yeah.
And config T. Yes. This is the what we have. So we need to define first keychain. So keychain name I define over there is we define the name over there is so I go for name is ABC. Okay.
Yeah.
And I right now I'm in keychain. Now I need to create the key. So we can create the multiple keys also. Okay, like imagine if I have a multiple key one, key two, key three, key four, like this. Okay, so we can create so many keys also. Like if I write over there key, and we can create how many keys? We can create that much amount of keys also in one keychain. Okay.
What use is to
What is
have
this? Like imagine that
more
if
than
I
one?
more than like imagine that if I'm using more than one key over there, like we have three keys, key one, key two, key three. Okay, so sometimes it goes for goes the authentication with key one. If my key one is if I imagine that I want that key one is expire, so it automatically goes to key two, and then it automatically goes to key three, like this. So there is a time interval, as you can say, that for key. Okay, so if I not using the key, like imagine that if I knows that someone is know the key one is already there, so what we can do, I can use key two over there, so it's automatically use the key two in that case. So we have a different keys also. Like if you want to go for a multiple keys, you can go for multiple keys too, but right now we can go for only one key. If you want to create only one key, so you need to find the number, on which number you want to create the key. I go for key one. This is my key one, as you can say that. Okay,
Yeah.
so we over there is key one is there. Okay, now enter it. Right now I'm in key. Now you give the key password. Okay, so the password you can go first key string. Now I define the password. So I define over there Cisco, or I can define over there 1 2 3 4. Imagine this is the password of my key. Okay, fine. Enter it. So now I successfully created the keychain, and under the keychain we have a key one, and the key one password is 1 2 3 4. Okay, fine.
Yeah.
Now if I need to run the authentication, so where I need to run the authentication, I need to send the authentication on my CL interface always. Okay, so I'll go for exit first. Go for exit again. Now I go to interface S1/0. I want to run the authentication on the router one has both the interfaces, both CL interfaces. So I need to run the authentication to both the interfaces. I go for IP rip authentication. Now I need to find my keychain name. So my keychain name is ABC, right? Okay,
Yeah.
enter it. So now over there I can run the authentication. So I go for exit and go for interface S1/1 also, 1/1 also, yes, and do the same thing. IP rep authentication keychain ABC. That's it. Okay, so now I set the authentication on RIP1. Okay, fine. Means router one. Now I go to the router two and I set the authentication over there also. So right now I click on exit, go for key space chain. I define ABC, the same name. I go for key one, and then the key string is 1234. Okay, fine. Now I go to exit, exit. Now I'll go for interface S1/0, and then I'll go for IP rep authentication. Okay, and go for keychain ABC. Same I can do in the second interface also, because we have two interfaces connected with the router one and router two. Okay, I'll go for interface S1/1/2 maybe. Sorry. Then I go for IP rep authentication keychain ABC, like this. Okay, this is the way how we can go for authentication. Okay, fine. Like we can same do in the router three as well. And go for router three. Okay, in router two we need to define the S1 also, because router
And
S1 connect with the router three. Okay, S1/1. Go for IP rep authentication keychain ABC. Okay, now I go
and
to the
if you do not, if we don't define on router 3, the RIP
so
doesn't
the
work
route,
at all.
yeah,
Yeah.
yeah, exactly. So means router three they are not able to get the updates, as you can see that. Okay,
Yeah.
understood. Fine. We'll go for config T, and same thing we can go for that. Let's go for key, sorry, space chain ABC, then define key. I can use the key number one and go for key string. It's 1234, and I define this, apply this authentication on interface S1/0, and go for IP rep authentication, then keychain ABC. That's it. Now all the routers successfully have the authentication method is there. Okay, so like this we can set the authentication methods. Okay, fine,
Yeah.
understood. So like
Fine.
this we can go for
Yeah.
that. Yeah. And now we have the option, one more option rep is auto summary. Okay, by default actually what happens by default, rep c shows the table in full format. Like if I full format means, like, imagine right now I have a very small table, as you can see that if I go to router one and if I see show IP root. So how many table we have right now? We have only 10, 11, 12, 13, 14, 15, 15 only six network is running in that routing table, right? Okay, fine. Now imagine that what I do, I can use some other networks. I can attach some other networks. So what I do, I need to, I want that my routing table is so big. Okay, so imagine I have so many networks is there. So like imagine I can insert some other loopbacks, as you can see that. I copy this, duplicate this, and go for duplicate this again, go for duplicate like this. Now we already have a 15, go for 16 over there, 17, 18. Okay, 19, 20, 21. 22, 23, 24. Now total I have how many networks? I have 24 networks actually. Okay, right? Not 24, starts with 10, so it's 14 networks actually. Okay, starts with
Yeah.
10 to 24, I have 15 networks I have. Okay, fine. Now we have the option, one more option is rep is auto summary. Okay, by default actually what happens, by default rep c shows the network Okay,
Mhm.
so now let's attach this networks with this routers also. So right now I'm in router 1, so I go for config t. So now why I'm going to for that, because imagine that if my routing table is that much big, okay, I have too many networks in my network. Okay, so rip, what rip do, rip always shows you the full routing table. Okay, so but I want that I need to see the summary only in the routing table. I don't want that rip always shows me the full routing table. Okay, it maintains the routing table summary in that case. If my routing table is so much big, so it maintains only the summary. Okay, so in that we have the option auto summary. By default, rip is not working on summary, auto summary. So if I enable auto summary on the rip routers, so what they shows me only the summary of routing table. It's not showing me the full routing table in that case. That I showing you. Let's see. You can go for interface, loopback 1 now. I'm using the loopback 1 because loopback 0 is already using loopback 1. L1, you can say it's a loopback 1. I go for IP address and go for 16.0.0, sorry 1, then 255.0.0. Go for no shutdown. Okay, I'm sorry, config T. Now go for interface, loopback 2. Over there you go for IP address 17.0.0.1, 255.0.0. No shut. Now go for interface, loopback 3, IP address 18.0. Okay, no shit. Okay, so if I go for check, show IP interface brief. So we have a loopback 0, 1, 2, 3. Okay, I can attach three loopbacks 1, 2, 3, 16, 17, 18 on router 1. So I need to assign these networks in the routing table also, means in the root also, means the rip also. So he is able to create the roots also. So router rip, and then we are using version 2, right? And then go for network 16.0.0, network 17, and then network 18, right? Okay, why I'm adding these networks on the router rip, because these are the directly attached networks on router 1. So we need to give the information also, no? So that's
It's
why,
uh, it's mandatory to always mention that we use version 2.
yeah, once we using the version, if I not mention the version, so it's automatically take the version 1, as you can see that.
I
Okay, if I
see.
not define the version 2, so it's not automatically take the version 1. Okay, so I go to router 2, and then you can go for exit and go for interface. Over there you have these. So I'll go for interface loopback 1, IP address, which is 19.0.0.1, 255.0.0. No shutdown. Exit. Then interface loopback 2, IP address 20.0. Okay, IP address 20.0.0.1, 255.0.0. No shutdown. No shutdown. And go to exit. Then go for interface loopback 3, IP address 21.0.0.1. Okay, go for show. No, not show. Go for, let's go for show IP interface brief. Okay, so loopback 1, 2, 3. All the loopbacks is configured. Go to config T. Go for router rep. Then go for version 2. Then go for network 19.0.0.0. Then 20, and then 21. Okay, fine. Now I go to router 3. Config T, interface loopback 1, IP address 22.0.0.1, 255.0.0. No shutdown. Then exit. Then interface loopback 2, IP address 23.0.0.1, 255.0.0. No shutdown. Exit. interface loopback 2, sorry 3, IP address 24.0.0.1, 255.0.0, then go for no shutdown. Okay, show IP interface brief. So 1, 2, 3 is okay, 22, 23, 24. Now I go to config T, go for router rep, then version 2, then go for network 22.0.0, then 23, then 24. Okay, fine. Now as you can see that if I see the routing table, so you can see that here I have so much long, I have 16 networks now running. I think so it's not running 24 because 24 is unreachable because there are 16 networks now. Okay,
Yeah.
fine. Not sorry, 16 networks maybe. So no, it's working because we need 16 hope counts. Okay, fine. It's running. Maybe just go for that show IP route. So you can say that we have a so much big routing table as you can say that. See how much routing, how much big routing table I have. Okay, so I'm not able to even manage these routing tables also. Rip also not able to manage this routing table because it's so much big. Okay, so what I need to do, need to tell you the Rip that okay, you need to use auto summary. So for auto summary, what happens when I say Rip using auto summary? So what happens in that case? In that case, what Rip do? It shows me the summary of routing table. It not shows me the full routing table in that case. Right now they're showing me the full routing table 17, 16, 19, 18, 20, 21, 22, 10, 11, 12, 13, 14, 15. It shows me all the IP addresses as you can see that, all the network routes. So now if I run over there config T and I go for router rep version 2 and over there I go for auto summary, enter, simple. I run the command auto summary. So now let's see how they're showing me the routing table now. Show IP route. So as you can see that still it shows me the full one. As you can see, yeah, she'll show me the full one. Just wait for full file. It's taking the time and let's it's automatically do give me the summary only. Let's see if I go to router 2 also and I set routing auto summary. Go for router rep version 2 and go for auto summary. That's it. I go to router 3 as well and set the same thing. Version 2 auto summary. Okay. So it shows me only the summary in that case. It's not shows me the full routing table. Okay, it means it shrink the routing table as you can see. This shows me only the main information about routing table. Understood? Okay. So how we can use the auto summary command? Auto summary command is this like this. Just simple go to router rep and go to version 2 and can go for auto summary because auto summary are support only router rep version 2. Rep version 1 is not support auto summary. Remember these things also. Okay. This is also the change in that. So we can use auto summary also in the rip version 2. Understood? Okay.
Yeah.
So this is the way how your how your router rip works. Okay, so I hope you're able to understand everything till now. Configuration of rip, difference between rip version 1 version 2, authentication, summary part. Okay, fine.
Yeah. Only the last thing is a little bit unclear. I mean, I don't understand what the change if we activate the
Auto
auto
summary.
summary.
It takes
Yeah.
some time. Takes some time, and it shows the difference only. Okay, it's only just what they're showing you. It shows you the summary of routing table instead of full routing table. Show me it maintains only the summary of routing table only. The
And
summary.
this summary is also what is communicated to the other routers, or is
Yeah,
just for me to
yeah.
see?
It's communicating the summary only. That's it. It's not completing. It's not sending the full routing table to all the routers.
Oh,
It sends the summary only. You can see that. The
I
summary
see.
means that it maintains only the summary only. That's it. It's not maintain the full routing table because imagine that if right now I have 16 networks. Imagine that if I have 50 networks or 60 networks in my network. in my company, I have run 60 networks. So imagine that how we able to manage that big routing table. Okay, so that's why we can use auto summary, because in other routing protocols, EIGRP, OSPF, over there the auto summary is running automatically. Okay, but
Yeah.
in RIP version 2, we need to run auto summary manually, because RIP version 1, version 1 not support auto summary, version 2 support auto summary, but it's not manually running, but it's not automatically running. We need to run manually auto summary command.
Yeah. I
Okay,
understand now. Yeah.
so like this what we have in the routing table. Okay, so this is what we have a RIP. Okay, I hope you're able to understand these things, right?
Yeah.
Now you're able to understand this. Yeah. Okay, fine. So this is what we have a router RIP. Okay. Okay. Now let's talk about the second protocol. If we already talk about the RIP version 1 and version 2 both, right? I hope both of you are able to understand RIP concepts. Okay.
Yeah.
Now on routing, we need to understand the now what is the issue? Now what is the loopholes in router RIP is, number one loophole is that we able to attach only 15 routers, not more than that. If I attach 16th router, so a RIP is not working on 16th router, as you can say that. It starts with router 1 to router 16. So router 1 is able to send the data packets till 15, not more than that. Okay, once if you want to ping with router 1 to router 16, so he's not able to ping, because router 16 for 16th device for RIP is unreachable, as you can say that. So this is the first very big, you can say that, disadvantage of router RIP
So so we can use RIP only on small
on small networks. Yes,
networks.
like if you have a 15 devices, so then in that case we can use RIP. If you have a more than 15 devices, we're not able to use the RIP on that cases. Okay, or this is the one major impact, a major drawback of you can say that in RIP. Okay, fine. So let's talk about the another protocol is known as, okay, and the timers is also very high in this. Okay, and it works on hop count. So this is the impact of that, you can say that. Okay, now the you can say that the problem in distance vector is, it talks about only the hop count. Now hop count means that, if you can imagine that, if I the second drawback, major important drawback in distance vector protocols is, like if you go for that, like imagine if you have this kind of routers connectivity. Okay, uh, like this, I have a routers. Okay, now this is the router 1, this is a router 2, and this is my router 3, this is router 4, and this is router 5. Okay, now these router connect with each other like this. Router 1 connects to router 3, router 2, and then router 2 connects to router 1, router 5, like this. It's connect like this. Okay, now imagine that router 3 wants to send the data packet to router 5. These all routers works on RIP, as you can say that. Okay, we're using RIP version 2 over there, version 2. Okay, over there also we're using RIP version 2. Okay, over there also using RIP version 2, same RIP version 2. Okay, and I'm using over there RIP version 2 as well. Okay, now we can go for that, like imagine that we can go for that, like, now what happens in that case, if router 1 wants to send the data to router number 5. Okay, so they had two paths, either they go via router 4, either they go via router 1, router 2, and this. So for via router 1, you need to cross one hop, two hop, and then third hop they have to reach. Okay, so he need three hops to cross. But if we talk about the router via router 4, he need to cross only one hop and two hop. Okay, so automatically it chooses the best path without router 4 home, router via router 4, right? Okay,
Yeah.
now in that case, imagine that it doesn't matter whether on the router 1 between router 3 to router 5, this router 1 via router 1 path, over there using 8 mbps 8 mbps wire, you can say that. Sorry, over there, over there, over there. Okay, and over there, imagine we can go for 2 mbps wire. Sorry, like this. So it doesn't check the capacity of wire, it doesn't check the delay. Okay, it just check the hop count only in that case.
Yeah.
Okay, so if he sees that the hop count is less, it doesn't matter whether the wire is slow or not. Okay, if he go via R1 and R2, so there is it has got 8 mbps speed. But if he goes via R4, so it get only 2 mbps speed to send the data. So it doesn't matter for RIP whether the delay is there, whether the bandwidth is slow or not. He just see the hop count only. So this is the drawback in distance vector routing protocols. So that's why we not use RIP and IGRP in the large organizations. Why? Because these are also very important impact on this. Okay, unless it has only 15 routers, means we can attach 15 devices only, and next the bandwidth, it not sees the bandwidth actually when it chooses the best path. Okay, so now
Yeah.
these things are means you can say that properly go for that in the EIGRP. EIGRP, you can say that if I go for EIGRP, so number one is known as enhanced interior gateway routing protocol. Okay, we have an interior gateway routing protocol IGRP. So IGRP we not use. We are using mostly EIGRP. Okay, before we go after it, we have a IGRP protocol is also there. Okay, so IGRP protocol also is the same, runs in distance vector. Okay, but it has more we can connect more devices as compared to the RIP in IGRP. Okay, fine. But if we talk about the EIGRP, so EIGRP, if we talk about, so it's the very first need to think, very first point we need to understand is that it is a Cisco proprietary protocol. Cisco protocol, as you can say that. We're not able to use this protocol on different routers. If you have a Cisco router, then you're able to use EIGRP. Understood? Okay, so it's a
Yeah.
Cisco router. Now, second point we need to understand is always that it works in both the categories. It works in uh, distance vector and link state. Okay, it means it uses hop count also, and it uses the bandwidth and delay metrics also. Okay, and it works on 3 topologies. As you already know that in link state we have a 3 topologies. Okay, fine.
Yeah.
Yeah.
Number third, number third, EIGRP works on dual algorithm, uses dual algorithm. Like your RIP uses Belford Bellman Ford algorithm. Over there it uses dual algorithm. Okay, to determine the best path, and it's a loop free network, loop free routing protocol. Okay, it avoids the loop also. With the help of dual algorithm, it avoids the loop also. If there is a loop occur in the routers, so EIGRP uses dual algorithm to avoid the loops also. Okay, number four.
What is loop-free routing protocol?
Loop free routing protocol means that it avoids the loops with the help of dual algorithm also. Dual algorithm do two things. Number one, it determines the best path with the help of bandwidth and delay, and number second, it avoids the loop as well. Okay,
Ah, yes, I understand. Yeah,
like in switch we have a STB protocol to avoid the loops, right?
yeah,
Like
I
same in
understood.
AIG, same in rep router we use EIGRP. EIGRP uses dual algorithm to avoid the loop as well. Okay, now you
Yeah,
go for EIGRP will form will form neighbor relationship. It's a very good concept in EIGRP, neighbor relationship. Sorry, relationship. It forms neighbor relationship between the routers. Okay, it means that if router 1 is not able to establish the relationship between router 2, so what happens in that case? Router 1 is not able to send the update to router 2. In that case, router 1 not able to share their routing table with router 2. In that case, so it's mandatory that router 1 is able to form the relationship between router 2 first. So there is a criteria on the neighbor relationship. I'll let you know what are the criteria. Okay, what are the criteria to form the neighbor relationship between the EIGRP routers? Okay, EIGRP works on AS numbers. So I already told you AS numbers. Remember
yeah,
AS numbers. So it works on AS numbers. Okay, EIGRP work on both the EIGRP works on unicast and multicast too. So it uses multicast IP address is 224.0.0.10. Okay, RIP uses 224.0.0.9 for multicasting, and EIGRP uses 224.0.0.10 for multicasting. Okay, means both the
yeah,
protocols are using multicasting. RIP version 2 only use multicasting. RIP version 1 do broadcast. Okay, now in EIGRP we have one protocol named RTP, is used to ensure delivery of is used to ensure delivery delivery of most EIGRP packets. Okay, so EIGRP works on RTP, Reliable Transport Protocol. It's a transportation protocol. So whenever EIGRP sends their packets, data packets, so it uses RTP protocol in that case. Okay, fine. Now, number 8, we need to understand is EIGRP routers do not send full tables every time. Okay, fine. It sends only updates, means whatever new in the, like imagine if I like imagine what happens in the RIP, in the RIP it sends complete table always every 30 seconds. It sends their complete table. Okay, but in EIGRP it sends only the updations. Like imagine if I have 6 networks, one 7 network is added in the router 1 EIGRP, router 1 in EIGRP. Okay, so router 1 sends the information about only that seventh network. It's not sends the
yeah.
complete table to the router 2.
But in the beginning, it sends the full table. Yeah,
Yeah, beginning of course. It's first time it's when sends the table, so it sends the full table. Once
yeah,
every router has the same table, then they send the updates only. Okay, fine.
yeah,
Whatever updates they have, only the new thing. Now EIGRP supports EIGRP. Okay, so that supports subnetting. Okay, subnetting and you can say that classless IP addresses. Number 10th, you can say that EIGRP supports other protocols also. EIGRP supports you can say that IP protocol. Okay, IPX protocol and Apple Talk 2. Now where we can use Apple Talk and IPX routing too. Like imagine in our Mac PCs, if I'm using the Mac PC, okay, if I'm using the iPad or the iPhones, okay, so in that we are using Apple Talk. We're not using the IP protocol over there. We're using the Apple Talk protocol. Okay, for communication, for networking. Like in Windows, in Microsoft we're using TCP or UDP. In Mac PCs we're using Apple Talk, and in Linux PC, Linux or Unix PCs we're using IPX protocols.
Yeah.
Okay, so if I have a different kind of PCs I have, like imagine I have Linux PC also, I have Mac PCs also. So if we're using the different kind of platforms in the AIGRP network, so we can use. Okay, but because RIP is not able to support IPX and Apple Talk, remember these things. Okay,
Okay.
number 11th, AIGRP AD value is, as you already know, 90 and 170. Okay, the two AD values. Now 90 AD values is for internal routes. 90 AD value is for internal routes. Okay, and 170 AD value is for external routes. Now, what is the meaning of internal and external routes over there? Internal route means if I'm using, all router is using the all router is using the EIGRP protocol. So over there we can use 90 and 90 AD value. Okay, like imagine that if I go redistribution, like imagine that some routing protocols are using RIP, and some routers are using RIP, and some router using EIGRP. So if I go distribution between the RIP and EIGRP, and once redistribution is there, so what happens? RIP sends their route information to EIGRP as well. So that route is mentioned is for that route is known as the external routes, and that routes AD value is 170 in the EIGRP.
And this is default, or we have to
No, it's default. This
change
is the
it? It's
default. This is
default.
the
Yeah.
default one. Okay. So
Okay.
this is the default one. So this is what we have. So if I go for redistributions, like imagine if RIP sends their information, their routing information or their routes information in the EIGRP. So EIGRP saves that RIP routes information with AD value 170, because EIGRP understand that these are the external routes. These are these are not my network routes. These are the external. These some other network routes are there. Some other protocol routes are there. So that's why it's mentioning the 170 in that case. Understood? Okay.
Yeah.
Yeah.
Now next we have EIGRP always works on, as you already know that, EIGRP uses which bandwidth and delay by default to calculate the to to calculate the best path. Okay, but in you can say that, but in EIGRP we have k values. It works on k values. You can say that. But in EIGRP EIGRP works on k values. Okay, so we have 5k values in EIGRP: k1, k2, k3, k4, k5. Okay, but by default k1 and k3 is working. So k1 value is k1 is bandwidth, and k3 value is delay, as you can see that. Okay, total we have 5k values. Now your EIGRP works on 5 values, as you can see that. Okay, it starts with like this: k1, then we have a like this k2, then we have a k3, then we have a k4, and then we have a k5, like this. Okay, so it starts with k1 is using for bandwidth, k2 is using for load, k3 is using for delay, which I already told you, delay, and k4 is using for reliability, and k5 is using for MTU. Okay, so by default your RIP works on bandwidth and delay. It means, and in the RIP by default k1 and k3 is running only. K2, K4, K5 values are not running by default. Okay, if you want to change the k values, if you want that I don't want to use k value 1 and 3, I want to use k2 and k4, so you can change the k values also.
Only two values is
Yes,
usable, or
by
more.
default is two values is using. You can use the
No,
five. You can use the five complete values also.
okay,
You
so you
can. You
can
can.
use all of them.
Yeah, you can all of them. But by default, it's using only two. By default, this is the by default one, and this is also the by default one.
Yeah.
Okay, we can use all of them as per the requirement, but by default using these two, K1 and K3. Okay. Now EIGRP uses the maximum hope count is EIGRP has a maximum hope count is 224. Okay. Okay, but you can say that, but by default it works on 100. By default it sets to 100 only, so we can if you're not changes anything in the max hope count, so by default it works on 100. It means by default we can get 100 devices, not more than that. Okay.
Yeah.
Yeah.
So this is what we have, the complete understanding of EIGRP. The last port, oops, sorry, I hope it's okay. So last one is 14.1. So EIGRP, as I already told you, it works on link state. So EIGRP supports three tables, as you already know. Okay, three tables. Number one, routing table, neighbor table, and topology table. Understood? Okay.
Yeah.
Yeah.
So that's what the characteristics of EIGRP. Okay. You need to understand these 13 points. So 14 points maybe. Okay. Now we'll need to understand one thing also in the EIGRP is also that how EIGRP forms the neighborship. Okay.
Yeah.
It's a very small concept. Neighbor relationship. So how we form what is the criteria to form neighbor relationship between the two EIGRPs? Router is number one is hello packets. Okay. Number two, AS number should be same to both the routers. AS number should be same on both the routers. Okay. Understood? This is the two point we need to understand. Okay. Okay. So hello packets. Remember that hello packets works on multicast multicast basis. Okay. It uses multicast which multicast address you can see that 224.0.0.10. Now what happens in that case, if I have two routers, imagine, and if I need to form the neighbor relationship between these two routers, remember always that EIGRP routers form the neighbor relationship through their neighbor only. Okay, which is directly connected, as you consider like this. Okay, so this is the router one, and this is the router two. Okay, now what happens? Router one sends the hello packets. Okay, you can say that router one sends the hello packets every 5 seconds. As you can, if your bandwidth is very good, okay, if your bandwidth is very good, so what happens? A router one sends the hello packet to the router number two. Okay, for every 5 seconds. You can say that. Okay,
Yeah.
understood. Okay,
Yes.
so by default it sends and it sends the four packets. You can say that maximum, not more than that. Only four packets. Like first five seconds it sends the first packet of hello packet. In that case, router 2 is not listening. Imagine. Now after 5 seconds, again router 1 sends the second hello packet. Again router 2 is not listening. Imagine. Now again after 5 seconds, again router 1 sends the third hello packet. Again not listening. After 5 seconds, again router 1 sends the hello packet number 4. Okay, still router 2 is not listening, so router 1 imagines that okay, router 2 is not able to make the neighbor relationship with me because router 2 is not responding the hello packets. Understood? If router 1 sends the hello packet and router 2 also give the acknowledgement of this packet, and he sends their own router 2 packets also. He sends their hello packet too, and router 1 also sends the acknowledgement to their router hello packet, and then after that it has the neighbor relationship with each other. So if router 1 sends the hello packet and router 2 not responding, so it means that router 1 and router 2 they're not able to make the neighbor relationships. If your bandwidth is very good, okay, it's very fast bandwidth you have, or you have a fast bandwidth, so then this hello packet sends every 5 seconds. Okay, if your bandwidth is slow, imagine that my bandwidth has I'm using 1 Mbps bandwidth. Okay, or you can say that I have using less than 100 Mbps bandwidth. You can say that like this, less than 1 Mbps. So it sends every 30 seconds in that case. If your bandwidth is low, router 1 sends every 30 seconds the hello packet. If your bandwidth is fast, then router 1 sends every 5 seconds hello packet. Okay, and it uses the multicast address 224.0.0.10 in that case. Okay, and their AS number should be same, remember always. If I'm using AS number over there 10, so it important that I need to set AS number also over there 10. Okay, if the AS number is same and the hello packet responds to the router 2 as well, router 1, router 2 also responds the hello packets, so it automatically makes the neighbor relationship with each other.
Yeah.
Okay, understood? Like this?
Yeah.
Fine. So this is what we have, the neighbor relationship form in the EIGRP. Okay, fine. Okay, so now take 20 minutes break and then we'll start with the 425 in my side. Okay.
Okay.
Okay, fine. Thank you. Okay, everyone is there, right?
Yep.
Yeah.
Okay, so let's do with the basic practical of I mean this EIGRP. Okay, and then we'll do the further things. Okay, in EIGRP. So first we do the basic practical. So for basic practical, what I need to do, I just go for there, and first I need to remove previous routing. Okay, so we already did with the version 2. So I go for config t. Simple go for no router rep. That's it. Enter it.
And this erase
Everything
everything on the
on the routing
IP
table. No, on
routing
the
table.
routing table. Yes, it is the routing. You can say they go for show IP routes. So it erased their routes, as you can see that. It shows me now directly connected network only. They're not showing me the routes which we created with the rep. Okay, so rep is deconfigured, as you can see that in router 1. Now go to router 2, same thing. Exit. No router rep. Okay, so just check show IP route. So all thing is now is gone, and then go for router 3 config t and no router rep. Okay, now let's see. Show IP root. So it's removed perfectly. Okay, now we need to configure the route, the EIGRP over there. So what we need to go for that? So I go to router one. Now go for config T. Go for router, then EIGRP. Now I already told you that EIGRP works on AS number. So if I define there, they ask me, you define the AS number between 1 to 65,535. You can define any AS number. You can go for that. Okay, fine.
Yeah.
So AS number I can define over there one on router one. So if I define one over the router one, so I need to define all the routers one AS number. If I change the AS number to different routers, so we're not able to communicate with each other, as you already know. Okay, so I can go for AS number one. Now now right now I'm in EIGRP, so I need to give the information about directly connect networks. Okay, so we'll go start with network 10 is a directly connected on router 1, then 12 is a directly connected, then 15 is a directly connected, then 16 is a directly connected. Okay, 16 and then 17 and 18. 17 also a directly connected network, and then 18 also directly connected network, like this. Okay, fine. So this is the way how we can configure the IP, how we configure the EIGRP. So router 1, in router 1 EIGRP is configured. Now I go to router number 2. Config T, router, EIGRP 1. Okay, then network starts with 11, 12. Okay, 11, 12, 15, 14, 15, like this. We go for 11.0.0, then 12, 14, 15. Okay, 15. After that we can go for 19, 20, 21. You can say that, see, the adjacencies are running. Adjacency means, if you see the adjacencies over there, it means that adjacency means the neighborship is created, okay, between the router 1 and router 2. As you can see that, see, it has two neighborship between the router with the help of 12.0.0.1 and the 15.0.0.1. It uses the serial cable, as you can see that.
Yeah. So
Okay.
the router 2 noticed that there are
Router 1 is a neighbor. Yeah, router 2 knows that they have
two
the two
cables.
interfaces. Yeah, so
Yeah.
that's why it connect its neighborship with created with these two cables. Okay, so
Yeah.
16 till 15 we can define. Now after that we have a 19, 20, and 21. 19, 20. Oops, not 21, 20. It's 20 only. 20 and then 21. Okay, so that's it. 19, 20, 21, right? Now I go to router number 3. Config T, then go for router, EIGRP1, then go for network. Now network, and there is 13.0.0. Then we have a 14. Then we have 22, 23. You can see that the agencies is created. Again,
Yeah.
24. Okay. So now you can see that if I go to router 1 first, router 1 is there. So show IP root. So as you can see that the see so much long table list. So as you can see that we have the load balancing also 19. If I need to right now I'm in router 1, and if I need to reach on right 19 network, so we have two cables, 12
Yeah.
and 15.
Mhm.
Okay, then again if I need to reach 21, 21 over there. Okay, so we have again 20, also we have a two cables connections. 21 also we have a two cables. 23 also have two cables. 22, 24. Okay, so we have a two cables. 13, 14, 15, 13, 14 also. In the reach we have a two cables. Okay, and this is the cost. As you can see that this number you can see over there, this is the cost. These costs makes with 10 raised to power 7 upon bandwidth plus delay. This is the formula to make this cost. Okay, fine. And this is the AD value 90. This is the AD value we're using by default. So right now I'm using the internal routes, the EIGRP routes. So as you can see that we have the EIGRP routes is there, but that's why we can go for D. D means we are working as EIGRP. Okay, if you have a EIGRP external route, so they're showing me EX over there. EIGRP external. Okay, understood.
Yeah.
So
Yeah.
this is what we have.
Yeah.
Okay, yeah. Now we go for router number 2, and we'll see this show IP route. So over there you can see that all the routing table is created. Okay, so if I need to go to 17, so we have 2 cables, 16 we have 2 cables, 18 we have 2 cables. So in that case you can say that in EIGRP this is known as equal cost load balancing. Equal cost means both the routes has same cost, as you can see that 2297856 for 12.0.1 and 2297856 for 15.0.0.1. So EIGRP doing by default equal cost load balancing. Equal cost means these two bandwidth has the same speed, same delay, same hope. After that, this is known as a equal cost. Understood?
Yeah. And
That-
Yeah.
if we change the speed of one cable,
yeah. So there is no
then
bandwidth.
we
So bandwidth
it,
is not running. So the load balancing is not there. That is known as an equal unequal cost load balance. You can go for that.
yeah,
Okay.
it will change automatically the cost.
Yeah, like I'll showing you.
Yeah.
If I change the bandwidth, like right, I went router 1. Okay, now I can change the bandwidth to S1/0.
Yeah.
Okay, so let's go for that. Go for show interface S1/0 first. What is the bandwidth right now? So the bandwidth is uh here it is. Here it is 1544 kbp.
Yeah.
Okay, I need to change it. So I'll go for, let's see how we can change it. First, I need to go to the interface first. Interface S1/0, and then we have the command bandwidth. Yes. Now I just define over there 1000 maybe. Okay. So ones, tens, 100,000, 10,000, lakh, 10 lakh, crore. Okay, so we'll go for 1 lakh. You can see that like this. It's around. It's when you calculate it, it's something about MB or MB something like this. Okay. So I change the bandwidth to this. Now let's see uh, what they show me the bandwidth. Show interface S1/0. Let's see. Now my bandwidth is goes to this much. Okay.
Yeah. We need to change it also in the other end on router 2.
Yeah. Okay. So let's see whether if you have any go for that. Like if I need to reach a network 14, so we have a load balancing previously, right? Okay. So now if we go for show IP route, so you can say that now see for 14 there is no load balancing in that case. See, it shows, okay, it's still shows me the load balancing. What we can do first, we can change that side also, the router 2. Let's see. um, show interface s S1/0. The bandwidth is 1544 kbit. Okay, go for config T and go for interface S1/0 bandwidth. That's it. Let's go for that. Show interface. Now it's changed the bandwidth to this.
Yeah.
Okay. Now let's see. Go to show IP route. Now you can see that there is no load balancing. If I need to reach 12 network, so it takes the only one path. See, oh sorry, it's directly attached. If I need to reach the 10 network, so it takes the only one path. See,
Yeah.
12.0.0.1. It's not taking the 15 one because the 12 bandwidth is high as compared to 15 one.
Yeah.
If I go to router 1, as you can see that, and go for show IP route. Right now I'm in router 1, and if I need to reach 11 network or 14 network, as you can see that. So here is any 11 network is showing me. Okay, sorry, I'll go for again. Here is see 11 network is it takes only 12.002. 12.002. Why? Because the
Yeah.
upper bandwidth is high, the lower one is low.
Yeah.
Okay, and if I need
And can we see the cost for the lower
no,
one?
you can see that. No, this is the cost. This is the cost.
Yeah, and
Higher.
for the 15.
15 one is this one. No? This is the cost actually of 15.
Yeah. Okay.
Okay, you can see the cost is changed automatically. Okay,
And the higher cost is better or the lower cost is better? The higher one, yeah?
no, the lower one.
The lower one.
Yeah, definitely. You can see that now. This is the higher one.
Oh,
280
it's 2 million. Yeah.
Yeah, and it's 6556 something. Yeah. So understand this. So Liz, you can say that if your cost is high, your bandwidth is automatically low.
So
If
the
the
cost
cost is low,
it's like money. The
you like
fewer the better.
you can say that like this. Okay, but and this, so if you can, your cost is high, your bandwidth is low, and the cost is low, the bandwidth is automatically high. Okay,
Yeah.
so this is what we have the load balance. So this is known as unequal. So once your bandwidth has unequal cost, means on the first we have on the means on the when the link 1 the cost is 65665600, and the link 2 the cost is this 2809856. So if there is unequal cost, so by default EIGRP not doing load balancing in that case.
Yeah.
Okay, but we can do load balancing also with the unequal cost too. Okay, if you want that, like you want that, I need to go still load balancing between these two links, so we can load balancing with the unequal cost too. Okay, so this you need to learn in CCNP, as you can see that. Okay,
Yeah.
so this is not a CCNA concept, but yes, we can. If someone asks you that if I have an unequal cost between my EIGRP links, so I'm able to go for load balancing or not. So yes, we able to go for that. But in that case, EIGRP not go by default load balancing. You need to do manually in that case. Okay. If the cost is same, in that case, like now, if I go for the same cost now, go for interface S1/0, and now I go for the bandwidth. We're using 1544, right? This is the
Yeah.
by default cost.
Mhm.
And I go to the router 2, interface S10/0, and the bandwidth is 1544. Now you can see that. Show IP route. Now it start load balancing again automatically.
Yeah. Show me.
Yeah, it's 10. If I see 10 network, so it shows me. So you can see that. Sorry. Mm, Now it shows everything. See, if I see that the cost is now equal on both the things.
Yeah.
Okay, fine. So if it is equal, if it is running equal costs, then we can do, then EIGRP automatically do load balancing. But if it's not running in the equal cost, so EIGRP not doing load balancing by default. It always used high bandwidth cost.
Mhm.
Low cost and uses high bandwidth. Okay, understood?
Yeah.
Yes.
This is what we have the by default concept of. Now we'll see the other things also. Like if I go to router 1 now we'll see the other tables. This is the routing table we can see. Now go to show IP neighbor table. Neighbor table or show neighbor table maybe. Show IP neighbor table maybe. And okay, show IP EIGRP neighbor table. Show IP EIGRP neighbors. This is the table. You can enter it. So you can see that right now in R1. So R1 has two neighbors. No, R1 has have only one neighbor, but it has two links. Okay. So that's why if you talk about the R2, so R1 is neighbor with R2. It has two links with the link of 15.0.0.2 also and 12.0.0.2. And it shows the port also. Okay, and the whole time of this labor is 14 seconds and the uptime is 7 seconds. Okay,
Yeah.
we learn these four things in CCNP. These four: SRTT, RTO, Q, and sequence number. Okay,
Mhm.
so this is what we have. Now, if I go to R2, so in R2, how many neighbors relationships we have? They're showing me three. Okay, because R2 neighbor is a neighbor of R1 because they have a two links. So that's why this shows me. And then we have a R1 also, R3 also its neighbor at 12.0.0.2. Okay. Now if I go to R3, so R3 only has one neighbor with R2 and it's only one link. Show IP EIGRP neighbors. As you can see that it shows me that I have only one neighbor with the port of this. Okay.
Yeah.
So in the neighbor tables, it shows their router 3 port. Means you can say the router 3 it shows their own port, as you can say that S1/0. So the S1/0 is our router 3 port. It now shows the next hop port in the neighbor table. Remember these things. Okay, fine. Now this is what we have. Another thing we need to understand is topology table. If I go for show IP AGRP topology, okay, and you can enter it. So this is a topology table, as you can see that. Okay,
Yeah.
Yeah.
you can see that it shows it saves all the paths. As you can see that if I showing you, if I go big, you can see that it shows you all the path. It have 10 network, 10 network also. It uses one successor. Now, what is the meaning of successor over there? Successor means one best path. We have two things: successor and feasible successor. Okay, in EIGRP we have two terms, as you can see that we have two terms: successor and feasible successor. Remember these things. I forget to tell you, sorry for that. I need to go for that. Successors and feasible successor, FS in short. Okay, now successor is a best route. Who is the successor? The best route. Okay, best route is a successor, and second best route is known as FS. Remember these things. Okay, so EIGRP maintains the successor as well as feasible successors too. So as you can say that it shows you that if I need to reach 10 networks, so we have only one successor, means one best path. If I need to reach 11 network, so we have two successors, means two best paths. Understood?
Mhm.
So like as
Yeah.
you
Yeah.
can see that, if I showing you over there, so if right now I'm in router 1 and I need to reach over there, the loop back 11, I need to reach over there. So we have two best paths, okay, with 12.0.0.2 or 15.0.0.2. Okay, so this is what we have this showing you, that we have two successors, two best paths. Their cost value
Mhm.
is this. This is the cost value of this. They are the cost value of this.
And if the cost would be different, we would have a feasible successor
Yeah, right,
in this table.
right.
Okay.
Understood. So there is no feasible successors right now. You can say that we have only successors in every path. In 12 network also we have successor only. In 13 network we have again two successors. 14 network we have two successors. 15 network one, 16 one, 17 one, 18 one, 19 two, 22, 21 two, 23, 24. Like this shows you all the information. Okay, all the
Yeah.
network information, all the
Mhm.
topologies. It shows you all 16 networks, as you can see that in this topology table. Okay, so you to understand is number one is successors, and we are able to understand the cost. Now, what is FD? You can see that we have the number is FD over there. Okay, and we have these things also. This is a successor. This is the successor. You're able to understand what is successors. Okay, feasible successor also able to understand. You're able to understand the cost also. This is the cost. Okay, and what is this? 128, 255, 256. This is known as AD. We have two things. There is not administrative distance. No, this is not that one. AD is advertised distance over there. In EIGRP, we have two terms more and need to understand is one is FD and one is AD. Okay, FD means feasible distance or full distance. You can say that. I know too many concepts are there. And number fourth is AD. You can say that advertised distance. Okay. Now full distance is that. Full distance means that. What is the meaning of full distance? Full distance is like, imagine if I need to reach over there, like imagine. Right now I'm in router 1. Okay. Right now I'm in router 1. If I need to reach over there, this network, 13 network, imagine. Okay. Fine. So how many cost we need to travel in that case? Over there is a cost. You can say that one cost is for this bandwidth. Okay, we need to see, and we need to see this bandwidth cost as well, right? Understood?
Yeah.
Yes.
Okay, and we need to see these two costs. So when I calculate all these two costs together, okay, that one has a FD value we have.
Mhm.
Okay, if I plus this cost and this cost between R1 to loop back, this cost too.
Yeah.
The full if I calculate all the cost, that is what we have a FD, full distance. In full
Mhm.
distance, you can calculate all the cost. Like imagine if I give you example, like imagine if I go for that, like imagine this wire cost is 100, imagine, okay, and over there also is 100, and over there in between R3 to loop back we have a cost, imagine 10. Okay, so total cost is what? To 110.
Yeah.
Sorry,
Yeah.
to 110. So this is the
1-0.
210. So this is the feasible distance we have. If I need to calculate the feasible distance, we can calculate the cost. Okay, understood, right?
Yeah.
Yes.
Now next we need to understand is we need to understand the advertised distance. Now what is the advertise? Advertise means like imagine. It's a very confusing point, as you can say that. Like I try to understand this. Also, uh, okay. Now let me go for the paint first again. Now if we understand the full distance, now we understand. Now we're going to understand the advertised distance. Like imagine. This is the router 3 we have. We have three routers, which is the diagram we're following: R1, R2, R3. Okay. Now we have a cost. So imagine this is the cost over there is cost is 100 over there. Okay. I'm using the cost over there is also 100, and I need to reach over there the loop back, as you can see that we have a network over there. Okay, and we need to reach this network. This network is 11.0.0.1. Imagine 0. Okay, and the cost between these is 10. Imagine. Okay, now router 1 says if I need to forward the information till 11. Okay, so my full distance is what is 200 to 10. Okay, my FD value is 210, right?
Yeah.
Now in that case, what happens now? Now router wants want to send the some information to this to 11 network. Okay. Now router 1 sends some information to the router 2 first. Now router 2 says that okay, if I need to reach there to 11, okay, if I need to reach there till 11, okay, so my FD is what? My FD is 110, right? Okay.
Yeah.
So if router 2 advertise router 1 information to 11 network, okay, understand this things carefully. if a router 2 wants to advertise the router 1 information to 11, so router 2 knows that that cost is a FD. But for router 1, this FD is known as AD, and the router 1 AD is 110 in that case. Understand?
Yeah.
Okay.
Yeah.
This is what we have, AD and FD. FD
So
is the full distance.
AD is the FD for the next hop.
Yeah, you can say that, and you can say that if router 2 sends advertise means router 2 going to send router 1 information to the destination, means 11 network. So from router 2, the value is 110. So that
Yeah.
110 is for router 1, that 110 is advertised distance, because router 2
Mhm.
advertise the router 1 information. Router 2 not sends their information. Okay, router 2 going to forward the router 1 information. So for router 1, that distance is known as advertised distance. Understood? Okay,
Yeah.
Yeah.
so that's what we have, a AD and FD. So what we have in this also, in the same, as you can see that we have FD, and this is what we have, a AD. Okay, so this is what we have. FD, you can see the FD, you can see the FD. Every destination, it's count the full distance. What is the full distance? You can see that every network, they have FD, 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 like this. Okay, so every network, it counts the full distance. Okay, if I need to reach between, like, imagine now if I go to my diagram. So if I need right now, I'm on loopback 10, and if I need to reach to loopback 11, so what is my FD and what is the AD in that case? So you can say that it shows like this over there. If I need to reach on 1011 network, so the FD is this 665600. Okay, understood? Clear?
Yeah.
Yeah.
Great. Okay, so this is what we have, the have things we have now. In this, we need to understand some package informations too. Packets information, like in EIGRP, we have so many types of packets running in the EIGRP. Okay, so just wait. 10 network over there we are using, 11 network over there we are using, 12, and over there using. Okay, now I make the diagram firstly, and then I'll explain you now. I already make the diagram now. EIGRP, EIGRP packets type. Okay, types of EIGRP packets. Number one, you can call hello packets. We already know this, right? Okay, which is box on multicast. Okay, box on multicast. We already know this. We already discussed about already this hello packet. Now next we have a update packets. Update packets. It works on unicast and multicast both. Unicast and multicast. Number third, we have query packets. It works on multicast. Reply packet. It works on unicast. Acknowledgement packet. Unicast. Okay. Now, update packet is already understandable that when router one sends the any updates to router two to their neighbor. Okay, so that's what we have, update packets. Okay, like in RIP we have update intervals. Okay, like same we have over there, update packets. So if any updates are there, if I need to send router one to send any updates to router number two, so it uses which packets? Update packets. Okay, and it's a unicast packet. Now, if we talk about the other things you need to understand is that number one is query packet. It's very important. Like imagine that. What happens in that case? What happened in that case? Imagine that if this network is down, imagine the 10 network is down. Example, okay? If the 10 network is down, what happens in that case? Router 1 sends the query to router 2. Okay, then he asks you, he asks router 2 that have you have any information about network 10, because in my side network 10 is down. Okay, now he waiting for his reply, router 2 reply.
Mhm.
If router 2 not reply, imagine that he sends 2 or 3 query messages and still router 2 is not reply. So what router 1 do? Router 1 remove the neighborship with R2 in that case, and he start forwarding, and he start broadcasting this network. He start searching this network actively. Understood,
Yeah.
Daniel?
Not,
Understood?
not quite.
Okay, again, I'll give you again. Let's see. Like imagine that what happens, my network 10 is down. Imagine my
Yeah.
network 10 is down. So what happens? Router 1 start querying to their neighborships, to their neighbor routers. Like imagine he get one query to the router 2. He asking router that you have any information regarding 10 network, because from my side network 10 is down. This shows me network 10 is not available in my side.
Yeah.
Okay, so if router 2 is not replying, imagine. So what
Mhm.
router one did, he removed the neighbor relationship from router 2
It's
automatically
not replying on the query
on the
about
query
the
about,
10,
yeah, yeah.
or
No,
is
he's
not
not
replying at
replying.
all.
No, he's not replying the query, as you can show that. Like imagine he asked some query, but router 2 not replying that query packet. Okay, so he removed the neighbor relationship in that case.
Hmm.
Understood?
I don't understand why it removes the neighborship.
He thinks that this router is not available, as you can say that. He thinks that this router is not a neighbor, not a part of my neighborship. So that's why he removed the neighborship, as you can see that, because he's
I
not
see.
replying, not replying to the query packet.
But
Understood?
the router 2 should reply that okay,
Yeah,
I don't have information about
yeah. So
the
then it's
10
okay.
network.
So then it's okay. So he broadcast this query. Then he do broadcast in the network to search this the network 10 information. In
Mhm.
that case, if he reply, if your router 2
I see.
replies that okay, I don't have any information about network 10. Okay, so what router 1 do? He's starting broadcast in that case. That's what we have, a replying packets. Okay,
I
querying
see.
packet
So
is,
so in normal fashion, the router 2 will respond that he has no information
yeah,
about the
exactly,
10 network. Okay.
exactly. If he's not replying, then he broke the neighbor relationship in that case.
Yeah, I understand now.
Okay, now the concept is that now in EIGRP we have some opposite things. Remember one thing also, if my network is available, so that network is called passive. Passive state means that network is known as a passive network or passive state. Okay, if this network is not available, imagine that if this 10 network is not available, it's removed, or you can say that router 1 is not able to get the information about network 10. So that network is automatically becoming a active state. And now what is the meaning of active state means over there is, means actively router 1 starts searching information about network 10. That's why we call it's active state, inactive state in the network 10. If network 10, if any network not replying or not available, that network is automatically, that network is known as a active state. Okay, and if any network is replying, or if any network is running in the network, okay, that network is a passive. Remember this thing, it's very opposite, as you can see that in the terms, as you can see that uh, uh, the network is replying, that network should be an active one, right? Okay,
Yeah.
but in the EIGRP it's opposite, as you can see that. Okay, so you can say that the passive state, or you can say that in that case is a very important, this very you can say that the passive state indicates that the root is reachable. Okay, remember these things. In the short, you can go for passive state indicates that indicates that a route is reachable. Understood this? Okay, and passive state indicates that a route is not reachable. It's very confusing and it's very you can say that opposite totally on this kind of things in EIGRP. Understood? Okay. Okay. So when router so imagine that if a router 10 route is not available, okay, so this network is automatically becoming active, and router 1 actively searching this network in the topology. Okay, fine.
So when we are sure about the network that is up,
Yeah,
it's passive,
yeah.
and when we are not sure, we are
So you can say that, no,
active.
like in this, we can see that. Like if I see the routing table, so they're showing me the passive. As you can say that. See, every route is in passive. See, network
Yeah,
P means passive. Okay, network 11 passive, network 12 passive, network 13 passive. It means these networks are reachable. If
and
imagine that if
if
10 is if 11 is not reachable, so they're showing me over there active A. It states me A active.
yeah, if we disable some ports,
Yeah,
probably
you
it
can
will
say that.
change. Yeah,
Yeah, it will change, right? Okay, or you can say that if any update messages are there, so it is showing me U. If any query messages are running, you can say that U, a Q, and if it is replying messages there, so it shows R like this. Okay, so like this is the status we have. Okay, and thus, so as you can say that every network by default is working as a passive. In if I see where if I go for show IP route also, maybe over there also they're showing me the passive. No, in routes they're not showing me the passive active, but in topology table only they shows the network is passive and active. Topology table only they shows the whether the network is active or a passive state or a update state, query state, reply state, which state they have. Understood? Okay.
yeah,
Yeah.
So this is what we need to understand. We need to understand is this. This is a very you can say that it's a very opposite type of things. We can go for that in the EIGRP case. Okay, fine.
yeah,
Okay, so now we already understand that the complete concept of EIGRP. So we already did EIGRP. Okay, so we'll see already the topology tables. We understand that what is successors, feasible successors, FD, AD. Okay, we'll see the topology tables, neighbor tables, routing tables, and we'll see the cost also. What is this? How cost comes? Because I already told you the formula is 10 raised to power 7 upon the bandwidth plus delay. Upon bandwidth plus delay. Okay, fine. So if you want to see the particular interface that how many delay we have, so you go for show interfaces, and then you can be showing you the delay as well. S1/0. So over there you can say that, see, the bandwidth is this much and the delay is this much u second. Okay, it's less
yeah,
than a millisecond, as you can
Mm-hmm.
see. It's less than a millisecond. U second is less than a millisecond. Okay, so this is what we have. Okay, so every port defines that how many bandwidth it's worked from and what is the delay. Okay, if I go to the Ethernet ports, like if I go for interface show interface f0/1, maybe f0/0 IP addresses, so you can see that over there also we'll see the bandwidth and delay. The bandwidth of this interface is this and the delay is this. So as you can say that if I comparison with fast Ethernet port and the serial port, so in serial port delay has delay is increasing, means 10 20,000 maybe few seconds. Okay, if we talk about the fast Ethernet ports, the delay is over is only 100 UC.
Mm-hmm.
So as compared to CL port and fast Ethernet ports, in CL ports delay is more, as well as why delay is more, because the bandwidth is low. That's why you can say that the bandwidth of fast Ethernet ports is like this, 1544 kilobit. Okay, but if I talk about the fast Ethernet bandwidth, it's go for 1 lakh kb. It means 1100 Mbps. Okay, like this.
Yep.
So this is what we have. That's why we have less delay in fast Ethernet, because the bandwidth is high. Okay. So we need to understand this also in this. Okay.
Yeah.
And I already told you that by default the auto summary is running in the EIGRP, so we do not need any auto summary command is there. If I need to change the hello intervals and hold time intervals, so we can change it also. Okay, so okay, so let's see that if I change the hello intervals, first I go for show IP protocols. Over there, how many hello intervals we have? If I go for there, like you can see the k values first. See the k values: k1, k2, k3, k4, k5. So k1 and k3 is running only. You can say that k1 is equal to 1 and k3 is also equal to 1. Rest k2 is 0, k4 is 0, and k5 is 0. So by default it's running k1 and k3, means bandwidth and delay. Okay, and if I see that, so over there we have the maximum hop count is 100 by default. Okay, we'll talk
Yep.
about the variance. We'll talk about the variance. Variance means in load balancing, how many percentage you can go for that. If you go variance one, means it's go 50-50%. Like if I need to send 4 packets, the 2 packets goes to first link and 2 packets goes to second link, like this. So variance command is used to set the ratio, that on which ratio it uses the both the best path, 50-50 or 60-40 or 80-20, like this. So variance one means it's by default 50-50. Okay, fine. And let's again I show IP protocols. So you can say that this shows me that the default gateway of the routing protocol services and the internal is 90 and the external is 170 AD value. This shows me the routing for network. So he knows 10, 11, 15, 16, 17, 18. These are the directly connected networks we have on the router one. Okay, so this shows me like
Yep.
this. Okay, and now we have a gateway. So gateway means that where these network, if I need to reach these networks, so what is the gateway? 15.0.0.2, 12.0.0.2, to reach all the networks. Okay, so as you can see that this is the gateway. Like right now router one, if I need to reach all the networks, so I need to go for there with 12.0.0.2 and 15.0.0.2. So these are the two gateways I have. Okay, where I need to exit and reach the other networks. Okay, so this is the last update is 16 milliseconds. That means it takes that much time to last update. Okay, fine. So what I need to go for that, if I need to change the hold on, if I need to see or change the hello packets, hello timing and hold on timing, so we'll go for imagine, go for config t first, go for interface s1/0. Okay, okay, will we first see the hello packets timing over there is go for show interface, maybe interface s1/0, and over there you can see that the hello keep alive set timing is 10 seconds, as you can see that. Keep alive is hello packet sent. Timing is 10 seconds, as you can see that. It shows me the packet timing over there also. Okay, if I see there, you can see that interface is up. Okay, keep alive time is 10 seconds. Okay, and delay is 0 seconds right now. Okay, so let's see. We'll need to change it. So how we can change it? I go to config t interface s1/0. Then I go for IP hello interval. After then, I need to define the protocol EIGRP, and then we can define the intervals. Okay, first we define the AS number. So my AS number is 1 we are using, and then we can define the hello packet seconds. Now what seconds you want to define over there? By default, it's 5 seconds, 5 to 30 seconds. Now you can define as per your requirement. Okay, by default is 5. I want 3. You can say that, like imagine. Okay, and enter it. So now hello packet interval is goes to 3 now. So every 3 seconds, hello packet send with each other, within EIGRP routers. Okay. Now there is a hold down timer also. So if I said I go IP hold time, okay, intervals, or you can say that hold hold intervals, or go for hold time, okay, with EIGRP and the autonomous one, and you can define the neighbor. Neighbor is considered down, okay. So if you see that I define over there, if within 9 seconds, if the if router 2 is not replying with the hello intervals, so it's considered that the router 2 is down in that case. So hold down time I can set to 9, enter it after that. So like this we can set the hello times intervals in EIGRP and hold down time intervals in EIGRP. Understood? Okay, fine. So if I'm showing you these timers, if I go for show IP EIGRP neighbors, in neighbors they shows me the hold down time. You can see that, see the hold down time they shows me. Okay, right now we are set to 9, so next update we go for that, shows me 9 over there. Okay, so like this is the hold on time, hold on a hold up time, you can say that, go for that. Hold time is 11 and 14 and all those things. Okay, like this, see it's continuously decreasing the timings, as you can see that. Okay, you can see that it shows 9 now. Okay, so like this again it shows the 12, again the update is there, again it's applying the hello seconds, and you can see that CLs go again 9. Again it's once it goes to 9, it again sends the hello packet. Sorry, I'm sorry. Go for show IP interface. Here it is, go for 12, and then again it goes to 9. Once this goes to 9, again the update is there. It's replying the packet, now it's goes to 13 again, because I give the 3 seconds. So after 3 seconds, it sends the hello packets, and when it goes to the 9, it again sends the reply that okay, I'm available over there. If we not reply with the 9 seconds, so what happens in that case? The neighborship is removed automatically, because he thinks that the neighbor is not replying with me. Okay,
Yeah.
understood. So this is what we
Yeah.
have. This is what we have in the EIGRP. Okay.
Mhm.
Now EIGRP also have authentication. Okay. So in RIP we can use keychains authentication with the help of keychain. Okay. In EIGRP we are using the MD5 protocol for authentication. Okay. I'll showing you EIGRP authentication too. The commands. You can see that like this. So if you go for the configuration, okay. So we can set the EIGRP authentication too. Okay. So like if I need to set the EIGRP authentication on the router one, so how we can go for that? First I go for enable and then go for config T. Okay, over there also we have the keychain concept is there. Okay, but in this we are using MD5 authentication protocol also. MD5 protocol also. Okay, fine.
Yeah.
So first I need to enable the EIGRP authentication. So I go for interface S1/0 and go for IP. IP authentication. Okay, then you can define the mode. Okay, so either you can go for keychain. So keychain is later. First you define the mode. So go for mode. Okay, and then mode we can go for EIGRP, and then they ask me the autonomous number I'm using is 1, and then we can use MD5 authentication over there. Okay, so like this how we can enable authentication in EIGRP. Enter it. So the MD5 authentication is enabled. Now I need to make the a keychain. So I go for IP authentication. Over there we have a keychain. Okay, now I define the keychain value. Over there is, before I define the keychain value, first I need to define the EIGRP1, and I define now the keychain value is, go for ABC in that case. Okay, let's see like this. Now I go to exit, and now we go define the keychain. So key space chain. Okay, and now go for, we have a ABC in the keychain, and now we define the key 1. Okay, now define the key string 1 2 3 4, same thing like this. Okay, understood. Okay, so like this
Yeah.
we have implemented authentication. Either you can first create the keychain, after that you can use, after that you can go for that the now you can see that once I enable the authentication, my agency is down. See, we have got one message. Have you seen the message?
Yeah.
With R2, my agencies is down because I change into authentication mode over there. So my agency is down, as you can see that. If I configure over there like this, if I go to exit now, go to interface s1/1 also, and if I go for uh, IP space authentication mode EIGRP1 MD5, enter it. So once you can see that over there also our you can see that agency is down because I set the authentication over there. Then again IP authentication, and then go for keychain, then EIGRP1, and then the keychain is ABC. Okay, we already defined the keychain already in this. Okay, so now if I set the keychain, if I set the keychain in R2 also, so then agency is automatically up. If I go to C, so this shows me that agency is down. See, authentication failure. Now what the reason this shows me? Authentication failure. Why? Because I set the authentication over there and not set the authentication there.
Yeah. We
Yes,
need to set
we need
the
to set there also.
authentication here
So I
also.
go to, I'm sorry, I go to config. What happens? Config T. Okay, config T, and now go for first go for keychain ABC, and then you can go for key one. Okay, and then we can go for key string 1 2 3 4. Then I go to exit. Okay, exit, and I go for interface s1/1. Sorry, source 0 first. This is the first, I think 0 1. Okay, 0 and /1 2. Okay, so I go to /1. I go to IP authentication mode EIGRP1, EIGRP1, and then MD5. Okay, then IP authentication keychain I can set over there is ABC. Okay, now let's see. It's up. Sometime it takes time and it's automatically takes to up. You can see that now. Now that the agency is up, its new agency is making interface s1/2 IP authentication mode EIGRP1 MD5. Okay, and then go for IP authentication mode, sorry, not mode, keychain ABC, and the EIGRP is not, first you go for EIGRP1 and then define ABC. That's it. Now I can say that it makes the agency with second interface also. See,
Yeah.
understood?
Mhm.
That's it. What we have authentication. So if I'm not set authentication on both the you can see that on both switches, sorry, routers. So it shows like this. Understood?
Yeah.
Yeah.
Clear? Okay.
Yep.
So like this, we have the EIGRP, RIP, basic of routing, static routing, all these things we have. Okay, fine.
Yeah.
So if you want to do practice, you can do practice. It's okay. Okay, and by my side, I finished the today's curriculum because it's more than enough. Maybe I think so. Okay,
Yeah.
and we'll do OSPF tomorrow. Will I just tell you which topic we did for tomorrow class? We'll start with OSPF, and then we can go for some part of BGP as well. Okay, and then we can go for ACL, and then we can go for NAT and PAT, and then last we can go for HSRP protocols. Okay, in HSRP we have some protocols, like we need to understand three protocols in this: VRRP, GLVP, and sorry, HSRP is the protocol. HSRP over there is FHRP, like this. Okay, so we need under these we need to cover these 5 topics tomorrow. Okay, so we
Okay.
Yeah.
complete the routing in that case. Okay.
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 So we will wait also for the recording for today.
Yeah, definitely. I'll send you the recording, not to worry.
Mhm.
Okay.
Perfect.
So I think Daniel, you have you give me the email ID, right?
Yeah, yeah.
You already give me the mail ID, right?
Yes.
Okay. Okay, then I'll send you the recording. You, Samuel. Samuel means take the recording in the second. He swap with the second. Now Denise and Daniel, you both you need, and Gabriel also,
Yeah.
right?
Yeah,
Gabriel,
and
I don't think so. Gabriel has the email ID because he not say me the email ID because you people work with that the girl name. I forget about the girl name.
I can give you Gabriel's address if
Yeah,
it
please send me
helps.
the Gabriel ID also. Okay.
Yeah, 1 second.